In this video, we are going through the entire June 2018 Maths Paper 2, grade 12 question paper. We are not leaving out anything. So obviously, the main idea is if you haven't gone through this paper, I think the best thing to do for yourself is to just like go through it first, and then you can just use this to like mark and check out what it is that you got wrong. But anyways, apart from that, for like much more deep explanations of everything that we're going to be doing, you can always check out the online courses on our website. The link to that is in the description. Anyways, let me not waste your time. Let's see here. It says the monthly profit, right, made by a company. This is in thousands, right? It said here the monthly profit in thousands of rands made by a company in a year is given in the table below. So for 3 marks, they said we should calculate the mean profit of, well, we should calculate the mean profit for the year. So the whole idea with this question is we need to remember that mean just means average. So for you to get the mean, I mean, like, you might as well just use your calculator, you see? So in your calculator, you're going to have to press mode, right? And then you're going to have to press stat, and then you're going to have to click where it says var, you see? And then you're going to have a column pop up there. So in that column, you're going to put in all these numbers, right? Each and every one of them. So let's just do that. Okay, so we've put in everything, right? Once you've put in everything, you need to press the following. So with all the data that you've put in, right, for you to get information on that data, what you need to do is you're going to press the on button. So let's just click, you're going to press the on button. After clicking the on button, you are going to press on shift, and then you're going to click on the number 1 button. This is if you're using the basic Casio calculator. You see, you're going to press on the number 1 button where it says stat at the top here. And then after you click that button, you are going to need to press var. You see, and then after clicking var, you're going to click on this option here, the one that has this symbol, you see, which is going to tell you, let's see what the mean is here. So our mean, which is our average for all this data according to the calculator, is going to be 190.25. Now the issue is here, you can see that it's a 3-mark question. So I mean, like, yeah, some may be skeptical to just leave an answer like this. So I mean, the idea behind the mean is you actually need to add everything up and then divide by how many numbers you're working out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you're dealing with 12 numbers, right? So the average is you're going to have to add everything up and divide by 12. So I mean, like, in terms of showing a calculation, we might as well just maybe do it manually for 3 marks, you see, so that you don't lose marks. So doing it manually, you'd need to add everything up. Adding everything up, I mean, like, you might also just use your calculator as well to give you the sum of everything. So the sum of everything, you can just click on shift, and then you can just click on stat again, which is the number 1 button, remember? And then you want to click on sum. You see, sum is going to give you the sum of everything, which is everything added together, you see. So once you click on sum, you're going to have to click on option 2. Option 2 looks like it has like a sigma thingy, you know, it has like a sum of x. This is what this sigma symbol, remember, means sum. So this is just going to give you the sum of all the values added together, of which the sum of all the values added together is just the number we're going to put here over the 12. So the sum of everything is just 2,283. Divided that by 12 is where you're getting the 190.25. So for 3 marks, I think it's best to do it this way. Okay, let's move on. It says here, we need the median profit for the year. So the median is going to be the value in the middle, okay? It's literally the value in the middle when you look at your data from smallest to biggest. Now the only issue is that if you're looking at your data, right, you have 2 values in the middle, because here you have number 1, 2, 3, 4, 5, 6, and then from the back end here 1, 2, 3, 4, 5, 6, you see. So we know that 171 and 169, those are going to be in the middle, you see, because it's like 12 numbers in total, you see. So we have to get the middle of those two. So meaning you have to add them up and then you have to divide by 2. So adding those up and dividing by 2, you are actually getting 170. But then they say it here, they need the median profit for the year. So this 170, you have to remember your data is in thousands. So don't forget to then say, therefore, 170,000 rands. If you leave it as 170, yeah, you might not get your 1 mark. So don't be that guy. Woo! For 2 marks, it says, on the number line provided in your answer book, draw a box and whisker diagram to represent the data. So when you're going to draw a box and whisker diagram, I mean, like, you only need 5 numbers, you see. For the box and whisker diagram, you need the 5-number summary. So, I mean, like, you want to check the kind of data you have here. So from 110 to 360, yeah, we have to be careful here. So let me just make a number line here. So this number line, let me make it until like maybe, I don't know, 400. But let me make it start at like 100. So let's put 100 over here. In the middle, let's put 200. In the middle there, let's put like 150. In the middle there, oh, no, bro, come on. 100 to 400. Wait, 1, 2, 3. Oh, what? 1, 2, 3. Oh, no, this is wrong. Oopsie. So from 100 to 400. Yo, how are we gonna do this now? What is in the middle of 100 and 400? So in the middle of 100 and 400, you're gonna technically have I don't know, 300. Let's see, 100. No. 100 plus 400 divided by 2. Oh, it's 250. Oopsie. Yeah, I was doing some funny magic there. So 250 is exactly in the middle of 100 and 400. And then in the middle of 100 and 250, you can just use your calculator. 100 plus 250 divided by 2. So me doing what I'm doing now, fortunately, you won't have to do anything like this because, I mean, like, you will have the, you know, the number line and everything. So in the middle of 250 and 400, we're gonna have 325. So 325. Okay, I just want to get the middle of these two numbers. I want to get the middle of each of these so that, you know, we can draw our box and whisker diagram. So in the middle here, you're gonna have like 137.5. You're now in the middle here. Let's see what you're gonna have. Because I just want to make a scale that's like, you know, like nice and stuff. So 250 plus 325 divided by the 2, you're gonna have 287 over here. And then, okay, let's just put 0.5 just for the vibes. So 325 plus the 400 there, divided by the 2, you're gonna have what? 362.5. So 362.5. Okay. Hey, yeah, it doesn't look very pretty, eh? But anyways, our box and whisker diagram, right? You just need 5 numbers. So the 5 numbers that you need is the minimum, the maximum, Q1, Q2, and Q3. So Q2 we have, it's the median, remember, Q2 is just 170. The minimum we have, it's 110. So 110. The maximum we have, it's 360. 360. So Q1 and Q2, this is how you find them. So Q1 and Q2, you're going to need to find the, what you may call, you need to be, well, you don't have to be, you know, this is not anything crazy or anything difficult, you see. So for you to find Q1, it's literally going to be in the middle of your first 6 numbers, you see. Because, or let's just put it this way, let's do things systematically. I don't even know why I didn't give myself enough space down here. Like, it's so dumb. But anyways, let's work this out systematically. So Q1, we can get it by using a formula that's going to give us the position of Q1. So the position of Q1, let's say here, position of Q1, you're always going to get it by saying 1/4 multiplied by n plus 1. So the position of Q1 here is gonna be, let's see what the calculator says, 1/4 multiplied by 13. So it's gonna be in position 3, around 3 point something. So the only thing is, I mean, like, it says 3.25, you see, 3.25. So obviously 3.25, I mean, like, it's going to be somewhere in between the 156 and the 164. So obviously what you may want to do there is you just want to add this up and then divide by 2. You see, so here your Q1 is going to be 160 because this is telling you just after position number 3. So for your Q3, position of Q3, you're gonna have a 3/4. Whoa. 3/4 multiplied by n plus 1, right? Which is gonna give you what is n? So it's gonna be 3/4 times 13, right? What does that give us? 3/4 times yes, like 3/4 times the 13 is like 9.7 something. So this is telling you just out of position number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you need to add these two up and divide by 2. So adding these two up and dividing by 2, let's see what you get. 192 plus 228 divided by 2, that's going to give you 210. Okay, that is nice, 210. Okay, fine. So now we have our Q1, Q2, and Q3. So let's put that data in our box and whisker diagram. So the minimum we got it to be 110. Come on, bro, get rid of this thing. Yes, sir. Yeah, that was not nice. So 110 is going to be somewhere over here. We can just label it. And then Q1 was 160. So 160 is going to be like somewhere here. See. And then Q2 is 170. So that's just before there. Oh no. Okay, this looks accurate. And then Q3 is like 210. So 210 is like somewhere over there. And then the maximum is like 360. So that's like somewhere over there. So let me just label these here. 170, 360. So this is like, let me just label these nicely now so that we don't get confused. So this is the minimum, maximum, Q1. Yes, like this is together, eh? Q2, and then Q3. What is it now? 210. When they say stay together, guys, they didn't mean so close, social distancing. But anyways, it is what it is. So let's see here, this, and then this. That line is not straight, bro. The line is not straight. The line is yeah, let me keep that onto myself. I don't want to get cancelled here. But anyway, so that's Q1, Q2, and Q3, and the maximum. That's your box and whisker diagram. Nothing crazy, nothing major. So this kind of took too long because somebody does not have grid paper. The next question for 1 mark. Any question that starts with hence means you need to use the information from the previous question. They say the hence determine the interquartile range. The interquartile range, it's just Q3 minus Q1. Q3 we got it to be 210. Q1 we got it to be 160, if I remember correctly. And our need is a calculator for that. We don't, but I might as well use the calculator. So the interquartile range here is going to be 50. So you have to remember that. Always remember to give your answers based on, the kind of data. The interquartile range is 50,000 rand. Remember your data here. They say the numbers they've given you are in thousands. So don't forget that, because sometimes you lose marks for nothing. For 1 more mark here, they said comment on the skewness in the distribution of the data. So if you're gonna comment on the skewness in the distribution of the what you call in the distribution of the data, that kind of work, right? You need to look at where your tail is, you see. So you need to look at where the part that's like stretched out is. So this is on the right hand side. So if it's skewed towards the right hand side here, you can just say skewed to the right. That's literally it. You get 1 mark. Skewed to the right, you see. And if you need more insight on all these kinds of things, you do wanna enroll yourself onto like the courses on the course platform. You see, the link is in the description. It is right here, you see, because there's a course for each and every topic that you need to work on in mathematics. There's stats, there's probability, there's everything, and it goes in deeper as well. So with the next question, it says for the given data, calculate the standard deviation. You see, this is where your advantage comes in if you have used your calculator for that first question, because getting the standard deviation here, in your calculator, right, you're just gonna have to say shift and then you press the stat button, say stat up here, and then you need to press the following: shift, let me just do it, shift, stat, wait, hold on, shift, stat, and then you need to press var, and then after pressing var, you need to press number 3. Looks like this. So if you press that button, right, your calculator is giving you 67.04118.759. You see, but remember, your answer needs to be in thousands of rands. So this is going to be, therefore, if you multiply this by 1,000, you're going to have this number. If you round it off to 2 decimal places, it's going to be 0.88. Okay, everything looks all nice and dandy. So that's all good. 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 Let me see here. Let's just carry on. For the next question, it says you determine the number of months in which the profit was less than 1 standard deviation below the mean. So these kinds of questions, you have to understand what they mean. They want us to determine the number of months in which the profit was less than 1 standard deviation below the mean. So what that means is you need to find what your mean is. You need to subtract standard deviation once. And then whatever this number is, and all the months that are below that number, you need to count them. That's the answer for this question. So our mean, we worked it out to be, what was the mean again? 190.25. So the mean is like 190.25, and then the standard deviation is like 67. Hey, yeah, and then this whole thing of not rounding off, hey, it's annoying, but it's fine. So let's just get this number here. So this number in our calculator is 123 point, let's just say 21 if you round it off, right? So you want to work out how many of the months are below this number. So when I work out all the ones that are below 123, so it's going to be only 2 of them. Yep, just 2 months. Only 2 months. Only 2 months are below 1 standard deviation away from the mean. Okay, let's keep moving forward, because why not? Anyways, question number 2 says the following. It says here, question 2. It is said that the number of times that a cricket chirps in a minute gives a good indication of the air temperature. Okay, and then it says the table below shows the information recorded during an observation study. Interesting. So the number of chirps here are giving us an indication of the temperature. So without overthinking it, if this was physics, we would have made temperature X and then the number of chirps Y. But then I'm like, this is mathematics. Funny enough, the way they give it to you, just label it as such. You want to make this X, you want to make this Y. Because the question here now says, represent the data above on the grid provided in the answer book. Well, we don't have a grid, okay? We don't got a grid. So I'm gonna have to resolve it. So I have to draw this thing. So, oh, nice, very nice. So with what I've drawn here, we need to put like a mini scale. Wait, let's see here. In terms of a scale, well, what does this thing not look straight? Don't mind it, Don't overthink it. So in terms of a scale, right? Obviously here, this is like 32 until 200. So I mean, like if we're gonna have 200 here, we might as well have 100 in the middle. Might as well have 0 here. And then in the middle here, we might as well have 50. In the middle here, we might as well have 150. In the middle here, 25. In the middle there, 75. In the middle there, 125. In the middle there, 175. Okay, I think this is good enough. And then this is from like 8 to 35. So we can go in 5s here. 0 until like 35, ne? 5. You're not. Yeah, this one. Hey, let's just do it manually. 5, 10, 15, 20, 25. Repeat. 5, 10, 15, 20, 25, 30, 35. Away, more second. away. So let's see, 25 here and then 30. Okay, this looks fine. So let us plot the points on the diagram. It says here 8 and 32. So 8, you know, 8, oh, we have to label it. So wait, let's see, chirps per minute, highball. Oh, chirps per minute is here, chirps, like chips, chirps per minute, and then here you have degrees Celsius, which is the temperature. Temperature in degrees Celsius. Whoa. Degrees Celsius, maybe. Anyway, so let's see, 8 and 32, right? So, oh yeah, 32 and 8 rather. So number of chirps is going to be 32. You. Yeah, I feel like this scale, yeah, this is rubbish. Like, bro, come on, bro. Like, ish. I'm not liking this scale. Okay, well, luckily, remember, you're going to have grid paper. So you don't have to like worry too much about my scale here. So between 25 and 50, ish, what do you get between 25 and 50 now? Man, this is, hey, I'll just make estimates. 32 would be like somewhere ish. Yeah, ne? Apologies. 30 will be like, 32 will be like somewhere there. 8 will be like there. 40 and 50. 40, let's somewhere there. 40 and what? No, 40 and 10, bro. Come on now. 40 and 10. 52 and 12. Okay, 52 will be like somewhere there. 12 will be below 15. And then it's like what? Come on, man. Luke. 76 and 15. Okay, 76 is at least just somewhere here. 76 and what? 15. 76 and 15. Yo. It's not looking bad. And then it says here 92 and 17. 92 and 17, somewhere there. 112 and 120. 112 and 112 and what? And 20, bro. Come on now. Focus. Okay, somewhere there. 128 and 25. Whew, 128. Yo, where are you gonna be now? Oh, look at me. Oh, this is 125. Okay, so 128 is close to that. 128 and 25. 128 and 25 will be like somewhere there. 180. Yo, that's a big jump, eh? 180 and 28. 28 is just above that. Okay. And then we have 184. Woo, and 30. Yep, somewhere there. And then 235. Yo. Well, I think the data kind of shows that, yeah, depending on the number of chirps that you're going to hear, it's definitely an indicator of the temperature, you see. So let's see here what we are seeing. Give me 2 seconds, okay? Give me 2 seconds. What do I need here? Wait, what do we need? We are done with this question. The next one says, for 1 mark, explain why the claim gives a very good indication is true. So they're talking about the statement here. It is said that the number of times that the cricket chirps in a minute gives a good indication of the air temperature, blah, blah, blah. So it says here, explain why the claim gives a very good indication is true. It is true because this data has a strong correlation. We can see it, you see? And also, it's almost forming a straight line. So let's just state those two things. The data has strong correlation and it is almost forming a straight line. Problemo, that's the way. We like it. The next question here says we should determine the equation of the least squares. Equation of the least squares regression line of the data. Well, this one is quite straightforward because I mean, like, the equation of the least squares regression line is just going to be y is equal to a plus bx. The a and the b value you can get in your calculator. by pressing the following. So in the calculator, remember you have all your data in your calculator, right? Yeah, you do. So you're gonna have to press shift, and then you're gonna have to press the number 1 button, the one that's written stat at the top there, and then you're gonna need to press SR calculator. Where are you? Shift, stat, and then you is going to, what is the next button here? I'm just going on my calculator now because this boy forgot. I'm literally just double checking. So it's like shift and then that button, and then you click on reg. Yeah, there we go. Reg for least squares regression line. And then after clicking on reg, obviously you're gonna have to choose number. You're gonna have to choose 5. I mean A there in your calculator. Let's see what the calculator is giving us, bro. Come on now. I feel like I was saying the steps, but I'm not like checking the answer in the calculator. So let me just put here. So we're doing here shift, and then we have to press the stat, and then we have to press the, what's this next button now? We have to press the reg, and then after pressing reg, we have to press A. There we go. We have pressed A. So A looks quite interesting. I mean, it is what it is, right? So A here is like 3 point, what is this? 3 point what? 3 point something, madam, or say. It's 3.97. 3.97. And then you do the same thing for B. Let's see what B gives us here. 0.15. So therefore, the equation is just y is equal to 3.97 plus 0.15x. That's the way. I like it. For 3 marks here, they said, predict the air temperature if the cricket chirps 80 times per minute. So predicting the air temperature has everything to do with your least squares regression line equation. Because I'm like, remember, if they're giving you the number of chirps, it means they're giving you x. You see, so they've given you 80. So 80 would fall somewhere there. So our answer should be somewhere around 15 and 17. Let's see if our, what you may call, if our equation is going to give us that. So this is going to be y is equal to 3.97 plus 0.15. What is x? X is Hyberman. What is x? X is 80. That's the way. It's going to be 15.97. You see, it is a good prediction. 15.97. So you can say here approximately 16 degrees Celsius. So that's a good enough answer. Nothing crazy, nothing major. So we shall move on. You see, this means approximately. Let us move on to the next question. Question number 3 looks all nice and dandy. I mean, like, you know, what does it say? In the diagram, A, B, C, D, let's see where A, B, C, D is. A, B, C, D. Why are you going anti-clockwise now, huh? A, B, C, D is a quadrilateral. It's not a parallelogram, it's a quadrilateral. Just has 4 sides. The vertices you're given there, it looks like all the coordinates are given. Wow, that's a first. And then it says yeah, M is the midpoint of BD. So M is this point here. It's not on the x-axis. Okay. Calculate the gradient of AC. Really now? Gradient of AC? Come on, bro. What you take us for? Gradient formula. So you're going to have to say here y2 minus y1, x2 minus x1. Okay, it doesn't matter which one you make x1, blah, blah, blah. So let's just say 1 minus the negative 4 there. It's going to be a plus. 7 minus the negative 3 there. It's going to be a plus. So there is going to be 5 over 5 over 10. It's going to be a half, positive a half, because you see this line would have a positive gradient over there. And there's no telling that it's going to pass through M. You know, if it does pass through M, it's just a coincidence. Yeah, purely a coincidence, meaning that hey, maybe this shape is not to scale, hey? But either way, bro, it's not a parallelogram. Next up, it says, what does the next question say there? The next question says, determine the equation of AC in this format. How? I feel like these guys just want to give us free marks. So any equation of a straight line, I'm like, this format is like, you know, is like premium stuff, this. So your Y value, you can just use any coordinate. Let's use positive numbers, boss. Let's work with positive numbers, because like, why not? Why not? So the 7 and the 1 is what we're going to use for our values here. So we're going to use the 1 for Y. Gradient is a half. Then we're going to use the 7 for X. Then here we just need to make Y the subject of the formula. So the 1 is going to go over, right? So here it's going to be a half times X, a half times the 7, and then the 1 is going to go over. So here your equation is going to be Y is equal to a half X. Wait, got an error here. This is over 2, bro. Excuse me. Wow. So your final equation here is going to be positive 5 over 2 here in your calculator. That no. Negative. Is it not negative, boss? Come on, bro. Come on now. Don't lose grip when you're almost there. So yeah, analytical geometry, the questions are super easy. So don't get too carried away like me here. Just easy moving forward without even checking. Anyways, let's see. For the next 4 marks, they're asking, determine whether M is on AC. This one is quite simple. We need to get the coordinate of M first, and then see if you put M, as in if you put the X and the Y value of M, you want to see if it balances out. Like the left side should be equal to the right side if you put the coordinate of M in this equation. That's how you're going to determine if M lies on AC. So to get M, obviously you may want to use B and D because they told you M is the midpoint. You see? So midpoint formula, let's go. So the midpoint is just going to be x1 plus x2, y1 plus y2, and then you're dealing with these 2 coordinates. So you can just say negative 2 plus the 8 there, negative 2 plus the 8, and then for the y values, it's just going to be 9 plus the negative 11 there. 9 plus the negative 11. Okay, this is going to give us positive 6. Yo, why am I even not using a calculator here? Like, you see, I'm busy wasting time here. 9 minus 11 is like negative 2. And then your coordinate of M, this is just going to be a 3, negative 1. Okay, so we said in our equation of our straight line here, we have to see if the coordinate of M is going to balance out the equation. So let's see here. Let's put this paste over there. So in our equation here, where y is, we're going to put negative 1. Where x is, we're going to put a 3. So this is like 3 over 2. And then let's see if the 2 sides balance out. Uh-oh. Yes, they do. That's because it's like 3. 3 minus 5 is a 2, right? Or 3 minus 5 is a negative 2, boss. So yes, it does balance out the equation. So we can say yes, M is on the line AC. So M is on the line AC, but we cannot say it's the midpoint of AC. It could be on the line AC, but it doesn't mean it's also the midpoint. Yeah. And then it says prove that BD is perpendicular to AC. So you see all these questions here, they're just, giving you 3 marks. Because if these 2 are perpendicular, it means that the gradient of one of these multiplied by the gradient of the other one should give you a negative 1. So what is the gradient of BD? We haven't worked it out yet. But the gradient of BD, I mean, like, you just use the gradient formula, bro. It's like y2 minus y1. So it's like negative 11 minus 9, negative 11 minus 9. And then you have the 8 minus the 2 there. 8 minus the negative 2. So that would be a plus. Ooh, let's put everything in the calculator. And I feel like I'm rushing, eh? But hey, you know what, Name? If you're confident in what you're doing, just move on. Just always make sure to always be checking your answers, Don't just, and the best way to check your answers, just check if they kind of make sense. I mean, like, anything looks off, then just obviously like disregard it. Hey man, put on silent, my guy. Why are you being so loud, man? Come on. But busy recording here. Ish. Yamar. AC, do we have the gradient of AC? Yeah, we do. We worked it out because we needed the equation of the line. That's just a half. So here's our calculation here. It looks like things are going to work out real good. So here we can clearly see that therefore the -2 multiplied by the half is equal to -1. You see, -1 is equal to -1. This is just a coincidence also that this is -1. This is purely a coincidence. So here we can then just say therefore the lines are perpendicular. So you can see for these standard tests, your basic theory is what they're assessing here. Because like look at these questions, they're quite straightforward. For 2 marks, they're asking for the angle of inclination of BD. So I might as well copy this image. So let us bring it down here. They're asking for the angle of inclination, and it's a 2-mark question. You're now. We have to cut you, my friend. Cut. You have to start that scene again. Let's make this smaller. That's just way too big, bro. So we need the angle of inclination here. Getting the angle of inclination, you just have to use your tan formula, you see, and you have to use the gradient of BD. So tan theta, we're gonna use the gradient of BD. And here we're gonna get a reference angle. And then that reference angle, you need to just, by observation, figure out if it's really this angle or the one on the other side here. And your angle, you should always, write it as a positive value. So here, tan theta, the gradient here we had -2. So remember, you have to get a reference angle. So your reference angle here is going to be shift tan with a 2. Never use the negative value. So always use the positive. Shift 10 with a 2 there. It's going to give you 63. 63.43. So that's this part, 63.43, you see. So therefore, theta is going to be 180 minus that. 180 minus this. You're just using it as a way to like, it's just a reference. Because I'm like, logically speaking, the 63 is this tiny part here. So 180 minus your answer is just 116.57. So don't worry about the reduction formula and all that shandies here. Just remember that this, you just use it to just, be able to just observe and see what the value of theta could potentially be. You see. Anyways, moving on. So the next question is asking for the size of CBD. How are you gonna know the size of the CBD now? Ask Uncle Google. Probably knows. But anyways, CBD. Where is CBD now? CBD. Okay, so it's an angle up here. So if you're gonna need to work out an angle that's like somewhere weird, don't focus too much on that angle on its own. Otherwise, your brain is going to pop. What you may want to do is try and like put this angle in like some kind of a triangle. So here it looks like putting it in this triangle is going to help. I extended that line deliberately because I want to make use of the fact that this is 116.57, right? So already 116.57 is equal to this angle plus the one up there, because exterior angle of a triangle. So those kinds of things, you should always be thinking about them, because those are the things that help you answer these kinds of questions. So it looks like we need to just get the angle of inclination of BC, because as long as you have this angle, you can just say this is equal to these two, add it up, and then you can just work out angle B up there. Let's do it. Let's get the angle of inclination of BC. So the gradient of BC, we need it. So let's get the gradient of BC. It's going to be y2 minus y1. So if you minus a -4, you're going to plus it. -2 minus the 3 there, you would plus. Let's put all these in the calculator. So it's 9 plus 4 divided by 1. 13. Yeah, but the line does look a bit steep, eh? Yeah, the line is steep, Shem. It's steep. Let's not lie. It is steep. So a gradient of 13 for this line, yeah, it doesn't seem too far-fetched, really. I mean, it is what it is. We're just getting what we're getting. So let us not be too arrogant, and let's just take the answer. It's 13. So the gradient is 13. So here you can say shift 10. You can just maybe even name this alpha. We're going to use it to get, we're going to use this reference angle. We're going to get a reference angle first. Our reference angle could be our angle, who knows? Reference angle is shift 10, 13 here. Let's see what this gives us in the calculator. Shift 10, 13. What you get? 84, 80, 80, 85 point something. Yeah, so this one is valid. This angle here is definitely our value of theta, I mean of alpha. Because I'm like, the angle there is an acute angle, you know? So this is definitely, we're gonna take this as the, whatever our reference angle is, we're taking it as the value here. Because remember, your reference angle, it should just help you to logically figure out what the angle is and where it could be on the line there. So here, we already know that 166, so we already know that 116.57 is equal to the 85.6 plus the angle they're looking for here, CBD. Like we know it, CBD. So here CBD, you can just isolate it by putting everything on the other side. What you get there? CBD, what are you? What is your angle? Calculator, please help us, because I'm like, why not, right? Like, why not? We don't want any trouble. Ons wil nie, blah, 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 blah. Insert Afrikaans words. Because my Afrikaans bundle, it has depleted. But anyways, this is giving us 30.96. Woo! Yeah, so the analytical geometry section, just keep on moving forward. Like, yo, easy marks this. The one, the length of AC, you see what I mean? Like, wow, guys, really? Distance formula, my guy, distance formula. So the dimensions, let's see, A is there and C is there. So it's like, let's see, 7 minus the -3 there, 7 minus the -3. And then you're going to have here 1 minus the -4. We're just using the distance formula, you see. 1 minus the -4. And all these formulas, remember, they're on your formula sheet. On your formula sheet. Because remember, the formula sheet will tell you things like what you may call x1 minus x2, and then that bracket squared, plus y1 minus y2, that bracket squared. That's just the distance formula. So in our calculator, let's see what this distance is. Distance, please, calculator. Okay, in the calculator, this is coming out as 5 square root of 5. But then if you're gonna round it off to 2 decimal places, if you press the SD button, it's 11.58. Wow, 5 marks. Okay, maybe a worthy opponent. Let's see here. Copy this question, paste it down here. So we need to get the area of a certain, a certain line. Let's see what line that is. So we need to get the length, the area of ABCD. So let's check out where ABCD is. Oh, the whole thing. You're not A, B, C, D. Yeah, the best thing you can do now is just work it out half-half. Because if you try to work out the whole thing at once, I don't think it's going to work out, hey? Not in this day and age. So we might as well do the whole thing. Because the whole shape, we might as well do it half-half. Because the whole shape is not a square, it's not a, let me just do a straight line, bro. Like, come on, bro. Let me finesse it. Let me finesse it quickly. I'm trying to say work it out half-half. So boom. Hey, Bosso, come on, man. Come on now. We're doing nicely. Oh, nah. Now I need to like do some shandy stuff here. Oh. You see now. This straight line does not want me to like, there we go. It worked. Just want to make it stretch until here. Nice. So you want to work this out half-half. Get the area of this triangle. Get the area of that triangle. Now you may be thinking to yourself, bro, how are you gonna do that, bro? Like, yeah. To be honest, let's try and figure out. Let's try and put into place the things they've asked us. They asked us for AC, right? Did they ask us for AC? Hey, but it looks like, why are they asking for AC now? AC doesn't look like it's really gonna be helpful. Because I'm like, whichever way, if you're gonna work out the length of this, the area of this triangle, you can use you can cut out your triangles, maybe use this one down here and then use the top one up there. It's literally up to you. But then I think the area rule is gonna help us best for this question. Yeah, the area rule, if we have angles and stuff, because here, remember, this is like 30.96, 9 something, 30 point what, 30.96. Yeah, so this is going to, let's see, for this triangle down here, we can easily work this out using the area rule, because we have an angle there. Yep, this does not look like a decimal, my guy. It looks like something else. There we go. So we have an angle there, and I mean, like, one or the other, we can use the distance formula to get BD and AC, then we're good to go. The only issue is for this other triangle up here, yeah, we don't have those kind of facilities. But it looks like we could get an angle up there, like if we really need it. It looks like we can get an angle up there, or even an angle down here. Yeah, this is where I think we kind of have to be creative, but without like being too jajarach, you know. Let's not be too much in a hurry. So if we're not going to be in a hurry, let's just lay out nicely what we're going to do. So we have this angle here, right? And we can easily get this length, which is BD, using the distance formula. And then we can also get BC using the distance formula. So we'll have two sides and an angle. We can just use the area rule for this triangle. However, we have another triangle, which is like BD, and then there's A there, and then there's D down here. You see, there's A here, D here, and then B up there. So I mean, like, we can also get this angle here, one or the other. Like, we can if we're committed. But bro, committed for what, bro? This no. I think it's best we try to get this one down here. I think this one down here is the one we can maybe get, because this one down here, I mean, like, if you look at it nicely, right, it looks like this one we can get it, because we can easily just get the angle of inclination here, you see, which is going to be this one because of vertical opposites. And then this is 60, what is this one? We got it as 63 point what? 60 something, 63.43, 63.43. So remember, this is 63.43, right? Meaning that this angle is also going to be 63.43. Let me maybe use a different color for this side so that we don't get mixed up. Because if we get mixed up, try like proper. So let's just get this. So this angle here, we can get it using the angles of inclination, and then this will be the vertical opposite. So once we have 1, 2, it's easy to work out this blue one because of interior angles of the triangle. So that's how we're gonna get this angle. After we get this angle, I mean, like, this distance here, we can just use the distance formula. This distance, we can just use the distance formula. Whew! So it seems like we're going to do quite a lot of work for just a 5-mark question. Now, to be honest, hey, Mina, yeah, it is I'm really not keen on doing it like that, you know, because yeah, there's really no reason, you know. I feel like there has to be yeah, some other way, because I mean, like, while thinking about, okay, this all this that we've mentioned, right, it's definitely gonna work, right, but it just seems like it's too much, you know, way too much for just the marks that they're offering us. So yeah, we kind of have to be creative. A, B, C, D. They're asking for the area of A, B, C, D. A, B, C. Yeah. A, B, C, D, E, F, G. So in my honest opinion, the only thing that I'm asking myself is, like, why did they even ask us for what is this? For AC, you know? Because I'm like, if they're gonna ask us for AC, there has to be a reason, man. You know, they really has to be a reason for them asking for AC. Yeah, because this method here, I mean, like, it seems like a long dry, né? But for 5 marks, I mean, like, if you cannot see any other way, I would rather just say go for it. But let me just look at this a bit longer. Maybe something will come up. Let me see here. This, do this there, do this there, do this. Let's look at it logically also. So they had asked us for AC in the previous question. So let's see what AC really is all about. So if you have AC here, right, it means that you have your two triangles split up in this way. There's a triangle down here and a triangle up there. So, oh my goodness. Oh my goodness. Oh, wait a minute. I think everything is coming together now. Because, I mean, we have BM, right? There's M somewhere here. Yo, this question is like so trippy right now because something just came into mind. So if you look at the kinds of questions they were asking us, what are the questions they ask us? They also asked us here to prove that these are perpendicular, like BD and AC. Where is BD? So there's B here and there's D there. BD and AC are perpendicular, meaning this is a 90-degree angle. Oh wow. Okay. If this is a 90-degree angle, that like changes the game like so hard. Like it's not to scale, né? But if this is a 90-degree angle, it means that we can just use half base times height to get the area of the triangle at the top and the triangle at the bottom. Because the triangle at the top, if you look at it nicely, it's literally just B. If we're drawing it nicely, it's gonna be BC with A like this, where you have this is M, remember. BM is perpendicular to AC. So it means that somewhere here you have M, right? Because remember, BM, they told us that, no, BC is perpendicular to, BD is perpendicular to AC. But then BD is just going out, is B going all the way to D passes through M, remember. In the questions that we're dealing with, all that was proven. So in this triangle, you can already see that BM is the height, and then AC is the base. So you can just get the area of this triangle like that. For the bottom one, same idea. You have C over there, A over there. Hey, I'm gonna have to plot this nicely here. Otherwise, it's not gonna come out. So at the bottom, you have C, you have A. So this is going to be the base. And then here, you have point D. And then obviously M. There's a 90-degree angle there. So here also, AC is the base. MD is the height. And then what do you have there? Yeah, base and height, you can just use half base times height. So we need to be careful. So likely we have the base for both sides. AC, we worked it out to be 5 square root of 5. 5 square root of 5. And then here also the base is just 5 square root of 5. And then here MD and BM. What other lengths did we work out? Did we work out any other lengths here? Nope, but it looks like we could. Let's see what we can work out. Because it looks like we can just work out the lengths of our heights there. Like those heights, we can just work them out, you see. Like what you call BD. We can work out MB using the distance formula. Because look, M to B is just going to be the distance formula. And then M to D, it's going to be the same thing because M is the midpoint of what you call BD. So if you get BM, you get both of them automatically. Or you can just work out BM, or you can just work out BD, and then just cut it in half because M is in the middle, you see, because you want BM and you also want MD. So the distance from here to there, we know it's the same as the distance from there to there because we know that they told us that M is the midpoint. So this question, yeah, it's quite trippy, but it is what it is. So let's just get BM, or rather, let me get BD, because why not? So let's get BD. BD is equal to let's just get BM directly because why you have to make it all complicated? Let me use a green so that it like pops, BM is equal to square root So you're going to have here -2. What is this distance? What is m again? Is m, what did we get for m? 3 and -1. Okay, so we have m there, 3 and -1. Okay, so it's like the distance formula is going to be -2 minus 3 squared. And then you're going to have your 9 minus 1. Okay, what you get now? Bm, right? -2 minus 3, that's like negative. Let's just put everything in the calculator, because like it's child's play this, eh? We're doing child's play things here. Just use the calculator, my guy. It's not grade 4 where they'll be like, you can't use your calculator. We can use it, so use it. Let's just see here, plus that. This is giving us 5 square root of 5. It's purely a coincidence. You see, purely a coincidence. 5 square root of 5, and then MD is also 5 square root of 5. Whew, okay. 5 square root of 5, purely a coincidence. 5 square root of 5. Whoa. When's in Johnny? There we go. When's in John? What are you doing? Let's see. So this is just 5 square root of 5. Hey, yeah, ne? I feel like this question is taking too long, but we're almost done. Half base times height. What does this give us? And then also down here, it's going to be half base times height. Let us see the answers in the calculator. So a half times the base times the height. What is this giving us now? 125 over 2. So this is 125 over 2. This is also going to be 125 over 2, obviously. And then therefore, you're going to say 125 over 2 times 2, which is going to give you 125. That's going to be your area. So they didn't give us specific dimensions here. So in terms of a unit, I'm like, you really don't have to like blow your brains out for that. You can just say square units. It's going to be 125 square units. So this question was quite interesting. I think with what we're thinking of in the beginning, it just shows how sometimes it's easy to do like a long drive. You can just make sure you use information of stuff that they have like asked you to work out. Because normally whatever you do work out, try and edit onto your sketch. Because if we were seeing this whole like 90-degree angle stuff, like it was going to be easier. Because the only annoying thing was not having to have drawn the line AC, because AMC, they're all in the same line, and then BMD, it's also all on the same line. Whew, quite an interesting question, but hey, let us keep on moving forward. Hey, let us keep on moving forward. No, 4, Haibo, question 4, man. It says here in the diagram, a circle having center, a circle in the diagram, a circle having center at the origin. Okay. Oh, nice. Passes through P. Where are you, P? Ukokai, where are you? You're here. Okay, origin, and then there's P. And then it says here, PO is the diameter of the smaller circle. Okay, so it's the diameter of the smaller circle, and it's clearly the radius of the big one. Yeah. And then it says here, it is the diameter of the smaller circle having center M. Okay, so this is good to this. And then it says here, the diameter RS of the larger circle is a tangent to the smaller circle. Oh, woo. Here, so much information. Is okay. You know, the more information you have, like, yeah, just think of a buffet, you know? Just take it slow. Otherwise, guess what? You're going to choke. That is not good for anybody. So it says here for 2 marks, calculate the coordinates of M. So calculating the coordinates of M, yeah, the fortunate thing is, likely they told us that this is the origin. So yeah, the moment you feel as though there's not enough information, just remember the origin, you already have information there. And M is just the midpoint of that, you see? So your M value is just going to be 0 plus the 4, and then 0 plus the -6. And then, what is your value of M? Is it 2 here, so is a -3 over there. Fantastic, eh? Is good marks. This free marks, you get your marks and you keep running. Don't waste time. Determine the equation of the large circle. Well, the equation of the large circle, I mean, like it's an equation at the origin. So it doesn't matter. Even if you did it like this, it's fine because you're still just going to put the center and stuff in this format. So the x value of the center is a 0. So you're going to put a 0 there. And then the y value of the center is also a 0. So you're going to put a 0 there. And then, bro, not then. Come on, bro. Hey, but then sounds better, you know. And then, so anyways, r there is the radius, right? Which is just the diameter, OP. So OP is too overpowered. No, it's not actually. We can just get the distance here using the distance formula. So OP is, what is it? 0 minus 4. And then 0 minus 6. I feel like here I made a mistake. Yeah, I did. No, it was supposed to be plus here. Ha, you see me getting paranoid already. Not even halfway through the paper. But anyways, we're making progress. You know, the whole idea is that we're making progress. So the one thing I always say is, if you're going to be going through these papers, yeah, make sure you at least have like gone through them yourself, or maybe you're like pausing, trying out the question, and maybe using this to mark or something if you're not like sure that the answer is correct, you know. Yeah, something like that. Because if you're just watching and sitting down, I guess maybe if you're trying to like learn and all that, then yeah, go ahead by all means. But because the thing with maths is you can't necessarily like make notes and stuff, you know. It's just like, oh, you know. So we have the diameter. Why did I work out the diameter? I should have just worked out the radius directly. No, but I only need the radius of the big circle, which is OP. Come on, bro, focus. Yeah, OP is correct. It's the radius of the big circle, but the diameter of the small one. So the radius of the big circle is just 2 square root of 13. Don't forget to put the square part. Otherwise, you are not going to have a good time. So this like this, trust me, you're going to get your 2 marks. Even if you have it like this, it's 100% fine. But then you might also just simplify it, you know, for future questions. 2 square root of 13, the whole thing squared. This you can put it in your calculator though, actually. So let us just do it. 2 square root of 13 squared is going to be 52. That's the way. We like it. I have to hunt down where that song comes from. I feel like it's from some movie or something. Whew. Anyways, oh yeah, let's take some time to plug the online courses. So the online courses, you can get them on this website. The link for that is in the description. And then if you, obviously on my side, if you need to ask like something specific, you can just hit me up on IG. Since you're here, I shall give you a discount code, BYB50. It's going to give you 50% off everything on the website. BYB50, it's going to be 50% off. Oh, no, it's going to give you 50% off the all access pass. Yeah, the all access pass. Woo! The all access pass, if you buy it once off, you're also going to get the study guide 100% free. Anyways, it says a small circle, we need to get the equation of the small circle. Determine the equation of the large circle. Here they're asking us to determine the equation of the small circle in this format. So us determining it in this format, it's easy because you actually have to start off with the original format. Start with the original format first and then like scramble everything afterwards, you know? Just like scrambled eggs. How do they start? They start all nicely in a ball. It's not a ball. All nicely in like an egg-shaped thing. In an egg, bruh. It's not an egg-shaped thing. It's an egg, an actual egg. But anyways, you're gonna start with this format, and then you're gonna throw everything, and then eventually like multiply out stuff. So for the small circle, luckily we know what the center is. The center is just this coordinate. So 2, you're gonna throw it here, and then for the center, you're gonna throw it over there, -3. See, that's the way. The radius is going to be the half of OP, remember. So OP, we have it. So half of that is going to be square root of 13 because it's like 2 square root of 13 divided by 2, which is square root of 13, bro. This is what radius is for this. See? Whoa. Why you got to make it all messy, bro? Come on now. Come on now. Bro, come on. The radius here is just square root of 13. But then don't forget the format. It has to be squared. So here you have to be careful now, you know. Two brackets that look identical. This is y plus 3, right? So you're just going to have here y plus 3, two brackets that look identical. And then 13 squared root of 13 squared there is just going to be 13, right? So x times x is like x squared. And then here minus 2x, and then plus 4. Y times y is y squared, and then plus 3y, and then 3 times 3 is 9. Nice. Okay. I mean, like terms, right? Like x squared is nothing. It's lonely. This minus this is going to give you negative 4x. And then let's check the format. We have to do the, yes, son. Hey, but don't worry about the format. You can do the format stuff later. The 4 plus the 9 is going to give you 13. And then y squared has nothing alike. So 3 plus 3 there is going to give you a 6 equal to 13. Now, because they want everything on one side and in this format, it's technically going to be x squared plus the y squared there. And the x's come first, so it's going to be negative 4x. And then the y stuff afterwards, 6y, and then the number afterwards, 13. Oh, 13 minus the 13 here, S-sign. Hey, hey, hey. Woo. Anyways, I feel like we're going to have to put a 0 there as a placeholder because, yeah. But I feel like we also, I mean, if you end up with a question like this, just check if your answer is correct. Just double check it nicely. So I'm putting the 0 here as a placeholder because of the E there, you know, but if you don't have the 0 there, it really doesn't matter. It is what it is. Is okay. Whew. Wow, man. Yeah, I feel like just blazing through this paper because I like some of these questions, if they're too easy, just move on. Just move on. So they want RS, it's a straight line. They want us to get the equation of the straight line in this format. Whatever they are going to ask for. I mean, like a straight line, you might also always start in this format because this format reminds you of what you need. You just need one coordinate that the graph passes through and the gradient. I literally paused and I was like, what else do you need, bro? What else? We need a gradient. So for RS, we just need the gradient of RS. Now the fortunate thing is, okay, the unfortunate thing is you don't have anything here, you don't have anything there. See, no coordinate. So this is where you have to think of your analytical geometry stuff. You have a line that it is perpendicular to. So you might as well get the gradient of OP and then use that to get the gradient of RS. Because remember, the gradient of OP times the gradient of RS should equal to -1. So let's get the gradient of OP. The gradient of OP, just use the gradient formula. Did we get the gradient of OP? Nah, we never got the gradient of OP anyway. So let's get it. So it's gonna be y2 minus y1. So let's just do it the other way. -6 minus 0. Okay, -6 minus 0. And then here it's gonna be 4 minus 0. 4 minus 0. 4 minus 0. Okay, so this is gonna be -6 over 4. Yeah, temptation. Okay, not a temptation. I was like, I'm going to use the calculator, and yes, I'm literally using it. Even though my brain is screaming out the answer, it's just something nice and safe about using a calculator, you know? So this is the gradient of OP. So already now you know that the -3/2, if you multiply it by the gradient of RS, it's going to be -1. So since you want the gradient of RS on its own, you're going to divide by -3/2 on both sides. See? Then the gradient of RS is just going to be 2/3. In your calculator, you will get it. So fortunately, we know we have a coordinate that the graph passes through. It's just the origin. Like RS passes through the origin. We can see it. It's like in our faces. So that's going to be x1 and y1. So we have everything for this question. Let us just, you know, did the does. We have 0 coordinate 0 here. This is x1, y1. I'm going to put it in there. This is y minus 0. And then the gradient we have 2/3 x minus 0. Okay, this is just going to be 2/3x with y here. That's the way we like it. So it's a positive gradient there, so it makes sense. You know, everything is looking all nice and dandy. So this is to also highlight that with paper 2 now, yeah, you can really bank some good marks. Where is this thing coming from here? Yeah. Let us move on to the next question. For 4 marks, determine the length of chord NR. Yeah, I feel like we should just get this picture down here now because it's too far now, hey? Come closer. Let's just get the length. Let's see here. Let's just get this picture first. Come on, bro. It's gone. No. What? This is weird. That was like super weird. I literally wanted to copy this thing, but I copied something blank. So let's try again. Let's try again. Open sesame. Feels like witchcraft now. But anyways, let me not be too extra. So they'll say we should determine the length of chord NR, where N is the reflection of R in the y-axis. So let's get where N is first. N is a reflection of R in the y-axis. So if this is R, it means that N is directly on the other side here. This is where N is. This is 90 degrees. See, whatever this is N. Meaning that the X value of R, we don't know. But then whatever its Y value is, it's going to be this Y value. So this we can name it X2. But then they'll have the exact same Y value because you see, it's directly on the other side. Whew. Okay, so you may think to yourself, why don't we get the value of R, the coordinate of R? Yes, let us do it. Because if you get R, the X value of R here, it's going to be very easy to get N. Because whatever the X value of R is here, this is just a reflection. And then as long as you have the 2 X values, the distance NR is going to be super easy. So the fortunate thing is R is the point where the circle, the big circle, and the straight line meet. So you can just equate the 2 equations there. Or you can just solve the equation of the big circle and the small circle simultaneously. You see, because remember, when you work out 2 equations simultaneously, you're working out where they meet. So this is the one equation. The other one is this one for the straight line, for the circle. So the Y value of the straight line here, you can throw it in there because you're trying to work them out simultaneously. Working them out simultaneously gives you the point of intersection. Just copy this thing here. Just remove this thing so that it doesn't confuse the peoples. Problemo. We need to work these out simultaneously. So equation 1, equation 2. We're going to take 1, throw it into 2. Okay. Yeah, this arrow is a bit, yeah. Hey, let's just do it. It is what it is. So it says here, y goes in this. So this is x2 plus 2 over 3x squared equal to 52. So here you have to make sure that your exponential laws don't catch you out. So this is going to be 4 over 9x squared because everything here gets squared. You see the 2, the 3, the x. Is like that. So this is technically, it has a coefficient of 1 here. So 1 plus the 4 over 9. Let's see what the calculator is going to give us because those are like terms. It's going to give us 13 over 9. So it's like 13 over 9x squared. This is a 5. So this is like, if you're going to, you literally just have to divide both sides by the fraction over there. So this is like 13 over 9, ka-ching, ka-ching. And then you have 5 here. This is like 13 over 9. That's the way. I like it. It's like 5 divided by that value, right? 5 divided by this value, you have 45 over 13. 45 over 13. And then what? You don't have to square root both sides. Let's just leave this as square root of 45 over 13. None of them are square numbers anyway. So that's the x value, but you have to put plus or minus because they meet at 2 points, you see. So the one that's a minus is the one here. The one that's a plus is the one up there. So you now know the x value of r, you see. The x value of r, well, we technically also need the y value. So for r, we know the x value is like positive square root of 45 over 13. We need the y value now. So to get the y value, we can just put that into the equation of the straight line because I feel like it's going to be easier to work with, It's definitely is going to be easier to work with. But let me just double check my answers here. Where's the 52? Oh, I wrote 5. Good Lord. Ek is jammer. Yeah. 2, 2, 2. Jajarach, my friend. Too much jajarachness. Let's see, 52 divided by that, it's gonna be 13/9. Whoa. Yeah, because like, I mean, answers with surds, you know what, just always double check them, you know, because it's like, where are you coming from? Not to say they're wrong, it's just like a good way to like, you know, pause and check. So let's just, you know, let's just stay humble because we were just humbled. Okay, I was just humble. You probably saw the error, you know, so meh, this is a +6. So in the equation of the straight line, I mean, like where x is a 6, we need to find out what the y value is because it's the easier one to work with. So this is going to be 12/3, which is a 4. That's the way. Okay, I'll stop. I do feel like I'm going to start sounding like a crazy person. So if as long as you have r, I mean, like it's going to be easier for you because with r, as long as you have it now, you know that this is 6 coordinate 4. So automatically, if this x value here is a 6, right, on the other side here, because it's like a direct reflection, you see there's the origin there, the center is nicely in the middle. So if this distance here is like 6 units, then going to the left, it's also going to be 6 units. But then if this y value is a 4, I mean, on the other side, it's automatically going to be a 4 also. So this is a 4, and then -6. -6 coordinate 4 is your value of n. So I mean, like they didn't ask for the coordinate of n, they asked for the distance. So from 6 to -6, that's like 6 units plus 6 units. It's going to be 12, boss. It's going to be 12. So n here is just -6 coordinate 4. Therefore, nr is going to be equal to 6 plus 6 because distance can never be a negative. And then we have got 12 units. Nothing crazy over there. Nothing too major over there. Let us keep moving forward. Let us keep moving forward, guys. Hey, we must keep moving forward. I'm busy saying let's keep moving forward, but I'm busy stalling here. Hey, it's fine. Let's go on to question 4.4 for 3 marks. The circle with center at M is reflected about the x-axis. Okay, to form another circle centered at K. Calculate the length of the common chord of these 2 circles. Yeah, I feel like for this, I kind of do need, you know, the image here. I feel like I don't know why this image is not copying. Like if it doesn't work one last time now, I'm going to be a bit disappointed. Hey? Oh, it worked. Okay, that's some scary stuff. But I mean, scary in a good way, I guess. Anyway, so we have this image. We have to just read this question nicely. I feel like I've gone through this question before somewhere. It looks way too familiar, like you're creepy familiar. Eh? You know that question that gives you creepy vibes? Yeah, this is the one right here. This is the one right here. Let's dive into it. Let us see, we just have to read this question nicely. It says, the circle with center M is reflected about the x-axis. So let's actually reflect it about the x-axis because we can do that, man. Hey, we can do it. So this circle is reflected about the x-axis. Oops, we cannot reflect it like that. We kind of have to read manually. So it's going to look something like what is it going to look like? Yeah, something like that. You know, something like this. You know, something like this. A little some. Let's just check it out. Let's make sure these things they touch it because they must touch. If you hit my stomach, how it is hungry. How I'm hungry, but we shall be fine. We shall be fine. Let us make this a bit thinner. You know, just for the vibes. So these touch at 2 points. Hella touch iso, and then hella touch aso. So they touch at the origin and whatever that other point is. So this is origin, 0 coordinate 0. We don't know what that is. We pretty much, okay, let's hope we won't have to care. So as long as it's a reflection about the origin, automatically it means that the distance from here going downwards. Yeah, okay, let's just check it out. So M, then the reflection of the center is going to be there. So it means that M and the new center they said here, okay, say the circle with center M is reflected about the x-axis to form a new circle centered K. That means with K, right, the x value of K is the same as the x value of M. So for M, remember, what was the x value of M again? We must check. It was 2. So it was 2 and -3, the coordinate, right? So we have to make use of it to help us, obviously. So here it was negative, it was 2, coordinate -3. So the one up here, you have to be strategic. Okay, you don't necessarily have to be strategic. You have to be just logical. Because if it's a reflection, right, it means that the x values are going to be exactly the same. So the x value, so it's still, you see, still same x value. That's a 2. Now the idea is from the x-axis, this was 3 units downwards. So it means that from the x-axis, this is going to be 3 units upwards, meaning this is going to be a positive 3. You see, I'll repeat. From the x-axis, this is 3 units down. So from the x-axis, this will be 3 units upwards. That's how we are going to do this, because these are just reflections of each other. So we have the point K. It says calculate the length of the common chord of these circles. Oh, so the common chord is this line here in between our green dots. This chord. How many marks are they asking for? Okay, how many marks are they giving us? They're giving us 3 marks. Well, we just have to find this x value here. I feel like getting this x value, it's really not something difficult, because we just have to, we can just equate the small circle equal to 0. The equation of the small circle, like we can just throw in our y as 0. I feel like this question is quite weird, because it's like the whole reflection, this reflection, that, it's just some stupidness. Okay, strong language. It's not strong language, my guy. It's a dumb question. It's a dumb question. Because no, man. No. They've been, man. They've been. Let's see. I mean, it's just a weird dumb question, because this question, they could have just asked us for the distance here by saying something else, but they had to tell us, you know, what you may call like reflection, mathematics always have to be extra. But anyways, let's get the equation of our smaller circle, right? Which is this equation here. And in that equation, we're just gonna make y equal to 0, because this point here, y is a 0. So we're gonna get 2 answers, right? The one answer is gonna be a 0. The other answer is gonna be that x value over there. So let us see what we got. In this equation, we're gonna make y a 0. So x squared plus 0 squared. Yo, we answered. What are you doing? Plus 6 with a 0 there. Do I really have to write a 0? Nope. Like, come on, bro. It's a 0, man. It's a 0 for a reason. Just exclude it. It has no feelings. So let's see here. This is gonna be x squared minus 4x equal to 0. Here we can factorize, you see. X minus 4 equal to 0. As expected, we're getting 2 answers. So clearly the x value here is a 4. You know? So the distance there, the chord length is 4 units. Very straightforward question, this one. So yeah. Let us keep moving forward. So yeah, let's move forward, guys. Forward we go. For the next question number 5 now, right? We're dealing with trigonometry. Dude, it's just trigonometry, guy. Side note, like the trigonometry course is the best course on the platform. Like legit. I'll give you a discount code because you're here. UIB50 is going to give you 50% off the all access pass. And then if you get the all access pass once off, you're gonna get the study guide 100% free. So the all access pass, I mean, the monthly installment is like $799. You can always cancel at any time. It's more like a subscription, but you can cancel at any time. So the discount code is gonna cut this in half, which is gonna make it 399.5, bro. The once off fee is like 2,999. So you can imagine this cut up in half because of the code is going to be like 1499.5. And you get the study guide. Free study guide. Hey, how do you spell guide, my guy? It's guider. Guider. I feel like I should color code it with the four what. Otherwise, we're going to confuse the people, bro. We don't want to confuse the people. So you get the free study guide if you get it once off. But then if you do just get it per month, I mean, like, it's up to you. It is what it is. The study guide on its own, though, is like 449. So study guide. Boso, uyenzani? What is doing? Study guide alone, guide alone. Yeah. You don't know how to spell alone now. Study guide alone is like 449. Free shipping. Free shipping nationwide. Nation wider. Okay. Whew, enough of that. It says here now, in triangle NP, N is 90 degrees. Okay, so might as well draw a 90-degree triangle. They said N is 90. Okay. So it's, no. N is 90, boss, not M. M, N, P. N is 90. And then they said sine M. So M is going to be opposite over hypotenuse. So sine M is opposite over hypotenuse. Did I put that? I meant opposite over hypotenuse. So this we can just work it out using Pythagoras before we even do anything. So we can just put here 17 squared is equal to 15 squared plus y squared. Remember that the hypotenuse is the one that should always be alone. Anyways, so we went y here. So getting y on its own, you have to square root both sides. So see what that gives us in the calculator. 17 squared minus 15 squared. What are we getting? We are getting something quite interesting. Or is it really that interesting? Nope. I'm just actually putting the wrong things in my calculator. But let me see here. Finally, it's giving us an 8. Okay, fantastic. Okay, so we can replace this with 8. Let's pretend we always had it. But even though we know we worked it out. So this is 8. Let's make it pop, bro. Make it stand out, bro. Come on now. Special treatment. Anyways, they say determine without using the calculator 10m. So they just mean give the ratio of 10m. You know, that's what they mean. 10m is going to be opposite over adjacent. Oh, heavens, another hour of algebra. So looking at where m is, this is the opposite. This is the adjacent. 15 over 8. You see, it's just like soccer toa. So, ka toa, opposite over adjacent. Adjacent over hypotenuse. Opposite over hypotenuse. Sine, cos, tan. Whew. Moving on. 3 easy marks. So you get your 3 marks because of your Pythagoras thing and the Hoshand is there. So with the next question, they said give the length of NP if MP is 51. What? You're joking. Huh? Nah, fam. What? I thought we did a what? Nah. No. I think this is error, bruh. Like, what? Give the length of NP if MP is 51. How? But then you maybe this is just a ratio, eh? But still though. Hi man, no. How many marks? Is a 2-mark question. Okay, yeah. So if it's a 2-mark question, I'm like, we may not want to panic too fast, but yeah, we just have to be strategic now, you know? Because I mean, like, you have to remember the 15 over 17. That's mainly representing this ratio in its simplest form. This is just what you may call NP and MP in its simplest form. Simplest form. Don't forget it, you see. So what we know is that MP, wait, is it MP? Yeah, MP, no, NP over MP. So NP over MP, no, hold on, bro. Don't be jajarach, my friend. Don't be jajarach. settled down. So this, we have to remember that they've given us this in its simplest form, which is just 15 over 17. So because we know this, right? I mean, you just have to think to yourself that the NP over MP, it's just a ratio. So this over this is just a ratio. You know, just take it as a ratio. So what we know is they said, what if MP is 51? So you're gonna have NP over there, 51 down here, and then this is just 15 over 17, because this is equal to this, and it is equal to that. So let's just deal with these two on their own, you see, because it's all three are equal to each other. So let's just deal with these two. So here you can just, you know, multiply both sides by 51, because you're gonna have here NP is equal to, in your calculator, you're gonna get the 45. 45. Whew. Yeah, this question was like, okay, in the beginning I was like, they're playing games with us. But I mean, like, you know how it is. Sometimes you just have to be creative. So let's see here. Simplify to a single trigonometric term for 4 marks. Well, I mean, like, the one thing I always say is anything like this, just try and flip it around, you know, because yeah, it's easier to work with when you're going to deal with the Cartesian plane and stuff. I mean, with the cast diagram. So 90 plus, if you're using a cast diagram, CAST, 90 plus would land you in this quadrant. So in that quadrant, sign is a positive. So you have to keep your answer here a positive. But then because you're dealing with 90, it has to change to a cos. That's like your basic theory that you need to know. And as mentioned, that kind of theory and all that, you get it from your course platform, and also like the basics on the main channel. Our main channel is actually Bright Young Brains, because I'm like, it is me, Levi, from Bright Young Brains. is going through these papers on this past papers channel, because I'm like, why not, you know? So you can get the basics there, but then, you know, the exam ready stuff, you're gonna get it on the course website. The link to that is in the description. So here, this is cos X. And the next thing is anything with a negative X here, as long as you're dealing with cos, you can just change it to a plus. See, the -1. So let's deal with this. This negative 60 plus X, always remember that when you're dealing with the negative, you have to go clockwise first. So you have to go negative 360, and then your plus an acute angle. So you're going to land up in this quadrant, because you're going to go negative 360, right? And then you plus an angle. So you end up here, in the first quadrant, of which everything is positive there. So as long as you're dealing with 360, the cos is a cos. And then this is what you have, plus cos squared x minus 1. This is going to be cos squared x plus cos squared x minus 1. These are like terms, so you're going to add them up. This should remind you of your double angle of cos, so this is just cos 2x. Well, that is the way we like it, because why not, right? Let us move on. Ain't got no time to waste. So for 2 marks here, they said consider this expression. It looks quite chunky, but I mean, like, just looking at it, remember where there's fuel, there's fire, because these repeat. This is reminding us of compound angles. They said write it as a single trigonometric term in its simplest form. Yeah, formula sheet, because in your formula sheet, let me get the formula sheet. Formula sheet, please help. Please come to the rescue. So on your formula sheet, right, you're gonna see that, like, whatever we are seeing there, it's definitely looking like compound angle stuff, you see. So anything to do with compound angles, I mean, like, why do you have to cram it? You don't have to cram it. You don't have to struggle. Just use your formula sheet. Because if you have your formula sheet, I mean, like, you might as well, right? You might as well. So with the question that we're given, it looks like there's sine and then cos and sine with a minus in the middle. So let's see here. Sine and then cos, a minus, and then cos and sine. So it's going to be this one, you know? So we're changing this thing to a sine. The whole thing here is a sine. Let me use a different color so that we can color code it and everything nicely. So this is going to be sine, right? And then let's just put a big bracket. So according to our formula sheet, you can already see that we're going to have here, as you can see here, right? We have the sine cos and then cos sine. Same here, sine cos and then cos sine. With minus in the middle, minus in the middle. So it means that this alpha is represented by the pink bracket. This beta is represented by the blue bracket. So the sign there, we're going to have alpha minus beta, which is just this bracket minus that bracket. So let us do it. We have to use you don't forget your brackets. Otherwise, this is where you mess up good. And don't mess up good. There's no point in messing up good. Like, what's the point, man? Just don't mess up at all. You know what I'm saying? Okay, that's weird. So let's see here. Sine x plus 40. This is minus x minus 30. And then what, bro? And then what? And then you have a h2. 2 minus 1 is like 1. So it's like 2x minus x is just x. 40 minus 30 is what? 40 minus 30 is 10, bro. That's a single trigonometric expression. So you're going to get all your marks there because you're a boss. Always be bossing it out. Plus, my guy, plus. Yo. Yeah, that was embarrassing. Easy here. Yeah, bossing it out. Making mistakes. But anyways, for 7 marks, I hope I gave myself space. Ish. Yeah, it looks like I kind of did, but let's hope I don't write too big. So they say we should prove that the left side determine the general term of the following. So the left side that we're given is exactly the same as this. So you might as well just change it to sine x plus 10. This is equal to cos 2x. So I promise you, things like, the trigonometric course on the website, right? Like, yeah, that's practically the best course on the website, because that course, all the courses practically go through like every topic, right, in different chapters. So for example, something like the trigonometry course, if I can just bring it up here. Oh, that's a coincidence. It looks like the trigonometry course is already here. So if you look at the trigonometry course, right, it has like 5 chapters. Chapter 1, which is going to be dealing with identities and trig expressions, simplifying trig expressions, which is what we just did. We simplified a trig expression. And then now we're dealing with general solutions. You see, so with trig expressions, examples, or questions, you can already see these are the questions you get, all these explaining in detail. Chapter 2 deals with general solution questions, different variations that they can ask you. And then after that, you're going to drill with trig diagrams and sketches, which is just like what we did in the previous question. This one up here, where you had to get the right angle triangle and everything. And then chapter 4, you're going to work with trig graphs, you see, detailed questions explaining trig graphs. And then lastly, chapter 5 is going to be the 3D and 2D triangles, you see. This is the trigonometry course. So, the reason I bring it up is because something like this question here, this is stuff that we kind of like explained in the course, because with these questions, all you have to do is you have to at least work with 1 trig ratio, meaning this you can change it to a sine. Meaning, remember, with your trig ratios, remember, just think of the reduction formula. In the reduction formula, cos theta, you want to change it to something that is a sine. So this is just going to be sine 90 minus the angle there, you see. So the issue is here we have 2x minus 20. So it's like cos 2x minus the 20 there is just sine 90 minus your 2x minus your 20. Like that, you see. Let's close this bracket over there. So that's what you're going to do on the right-hand side, you see. So here you have sine x plus 10. And then here you're going to have sine 90 minus 2x minus 20, like that. So from here, you'll be able to like drop the signs on both sides and then carry on and everything. But I'll just tell you a secret. Okay, not a secret per se. It's just more like a personal preference. So in my own personal opinion / personal preference, and I can't get too deep as to why it is my personal preference with regard to what I'm about to say, but then as a personal preference, right? So speaking of personal preference, Like, I believe it's just gonna make your life easier. Now, when I say my personal preference, I'm referring to this. I would much rather change everything to a course because, yeah, it's not necessarily just a personal preference. It just allows you to use this specific method all the time and be fine. So in terms of us changing the sign instead, I mean, you can change both, but I would prefer changing the cos, and you'll see why just now, especially for things like this, because it's the same idea here. This, you can just write it as cos 90 minus this angle, right? There you go. And then here, this is just cos 2x minus 20. The reason we're writing this out is because we also know that sine theta is just the same as cos 90 minus theta, you see. So the theta there is just this x plus 10. There you go. So the idea is, as long as you've written it out like this, right, what you want to do is you automatically want to split your page in half. And then once you've split your page in half, all you do is the one side here, you're going to just drop the cos's. You see 9 minus x plus 10 equal to 2x minus 20. The other side, what you do is this part here, you always write it as a negative. 90, and then bracket there, x plus 10 equal to the 2x. So you changing both sides to a cos will always allow you to do this, which will always allow you to eventually get your correct answers. You see, you drop the cos's one side, you take whatever is in the brackets the way it is, you see. So in terms of this big bracket here, you just take that, drop it on the left, and then this bracket here, just take it, drop it on the right. And then for the other side, you just have to take this as a negative, and then this as it is, and then you'll always get your two answers, your two sets of answers. So carrying on from here, you're going to have 90 minus x minus 10 equal to 2x minus 20. Let's take everything on one side. You're going to have here 90 minus the 10 plus the 20. What you get here? The x, you're going to take it over. It's going to be 3x, right? So here, let's see what you get. You're going to get here, highball. This is like 80 plus 20. That's 100. Okay, got 100. 3x is equal to 100. So here you have, let's just maybe write this the other way around because it's easier to work with. 3x is going to be equal to 100 plus k360. K is an element of integers. We just wrote the 3x first because it's easier to write it like that, you know. So let's divide both sides here by 3. What you're gonna get when they come for you, plus k120. K is an element of integers. Perfect. Now with our other side, we're gonna do exactly the same thing. So here you can multiply, I mean, like, you can deal with what's inside here. 90 minus x minus 10, right? And then 90 minus the 10 is going to give you an 80. And then you know that here you have like negative 80 plus x equal to 2x minus 20. And then, yeah, I'll stop now. So this is just like, so the 3x, the x goes to the other side, you're going to have 3x. This goes to the left, you're going to have negative 60. Uh-oh. No, bro. When the x goes over there, you minus, bruh. Come on, man. Come on. Focus, my guy. 2x minus x, you're going to be left with x. For future answer, you're going to say x is equal to negative 60 plus k360 has an element of integers. You see, that's why me changing to cos is a personal preference. Because as long as you change to cos, you'll always be able to do this bracket, one side, this bracket, other side. And then what you then do is you just make this one a negative. The side where you would have done the whole 90 thing, make it a negative. That other side, you leave it the way it is. And then you carry on. So that's going to give you your marks. So let us move on to the next question, which is this question. Anyways, we are here at question number 6. It is clearly a trigonometry question. It is trig graphs. Trig graphs. What chapter is this in the course? I think trig graphs is like chapter 3 in the online course for trigonometry on the website. So the link to that is in the description. Anyways, it says here in the diagram, right, the graphs of f of x is equal to this. So where's f of x? So this is like a portion of a sine graph. So don't get confused. This is just like a portion of a sine graph. And then it says here, in the graph of G is this part here. So this is just also a portion of a cos graph. Now, with all this being said, we need to also be able to recognize the different meanings of all these different words here and wherever they are. So the idea is, remember, with all functions or with all trigonometric graphs, they will always be in this format. Let's just use sine as an example. Sine here, and they'll have like bx, and then minus p, and then plus q. So already in terms of the theory that you need to know, I mean, that's like mainly covered on the online courses. You need to know that this is amplitude, this is the frequency, this is a shift from left to right, this is a shift from top to bottom. So this number, right? I mean, like here, you always take this as what you may call, if it's a -3 here, it means that the amplitude is a +3, because remember, amplitude is more like distance. And then here, as long as you have half x here, automatically you want to look at this as sine with a half in front of the x there. Now this is telling you your frequency is a half. Now if frequency is a half, it means that you have half a graph in a space of 360 degrees. You see, that's what frequency means. And you can always work out the period using the frequency formula, because the frequency formula has period in there and frequency. You can either work out one of the two, depending on what you need. In this graph, we can see the amplitude is a 2, and this graph was shifted 60 units to the right. Woo! So this is all drawn from -180 to +180. I mean, like, this is a span of like 360 degrees, you know, technically speaking. So yeah, we should just keep that in mind. And then it says here t is this coordinate. So t is somewhere down here. We are not given any p or q value. And then they said it is the turning point of G. And then they said p is smaller than 0. Like, I mean, like, it's on the negative side of the x-axis. So it's definitely a number that's smaller than 0. This is just some weird dumb things that they put there. Right? Yeah. Ne? Anyways, they want us to get the period of f for 1 mark. So, I mean, like, as mentioned already, if you need to get period, you can just use this formula. It says here, frequency is equal to 360 degrees divided by the period. This is for a sine or a cos graph. If it was a 10 graph, you would put a 180 where the 360 is. So for f, we mentioned that this is amplitude, right? And then we know that this is frequency. Frequency, because frequency is going to be this value here that will be in front of the x. So anyways, that being said, frequency, we know it is what, a half, right? So we're gonna put a half over here. This is equal to 360 over, let's just say p. So to put p on its own, you can cross multiply here. P times 1 is a p. 360 times 2 is a 720. So a period is how long it takes to get a full graph. So the number of degrees it takes to get a full graph is 720 degrees. That's the period. Frequency tells you how many complete graphs in a space of 360. So that's why here in a space of 360 between 180, between 180 to -180, you technically have half a graph here. You see, that's just like a portion of a graph, a full graph. So they want us to get the range of G. So in terms of the range, I mean, like, it's all about the highest point that the graph goes to and the lowest point that the graph goes to. So if you know your theory, you know that this is technically the lowest value that it goes to. This is the highest value that it goes to. Now you can just figure out these values just by looking at your standard form. So according to your standard form, your frequency, your amplitude there is a 2, meaning that another thing to look out for is if there's a vertical shift. There's no vertical shift here. You see, the graph was not moved up or down. So amplitude is a 2. It means that the distance from this point of rest until the highest point is just a 2. And then also here, the distance here is also just a 2, you see. So the amplitude is a 2. Meaning here, down here, this is -2. Up here, this is +2. So the range is just from 2 to -2, where both the 2 and the -2 are included, because the graph does touch -2, the graph does touch +2. So range here, you're going to say y is an element of -2 until +2 with square brackets over there. and by using the square brackets because the graphs do touch these points. Easy, 2 marks. Woo! Okay, so for 3 marks, they said we should calculate this. Well, the fortunate thing is, wait a minute, P. You're now. Let's look at what P is. P is the X value of our turning point. Now, fun enough, we can work out the value of P if we know our theory well. So according to our theory, I mean, like this value here is going to be -2. That's the Q value. Now the P value, you have to be, you don't have to be too strategic, really. You just have to think, you know, logically. So this was moved 60 degrees to the right. So technically what you want to think to yourself is, what you had in the beginning, yeah, was a standard cost graph. A standard cost graph will look something like this. And then on the left, it'll look something like, oh, yeah, that escalated not very well. So this is a cost graph from 360 to -360. Now the idea is you already can see that the equation of this graph would have been y is equal to cos x, you see. So if this graph was moved 60 degrees to the right, then you'd have -60 here, and then the image, wait, hold on, before moving it right, let's take note of like some key x value. So here we know this is 0, this is like 90, I think this is 270 because in the middle is 180, and then here this is like the 360. So these are some key values that we know, right? Now what you can take note of is that on the left side this would be like -90, this would be like -180, this would be -270. So what's important is to know what this turning point would be. Say the amplitude of this graph was a 2, right? It means that this would go up till a 2 up there, would go down to -2 up there. This is what the image would look like. So what we're trying to do is, if this graph was moved 60 degrees to the right, like this, right? What it would look like is that this whole image here, right? It would just move 60 degrees to the right. Yo. When's in Johnny, bro? Come on, when's in Johnny? Yeah? When's in John? What happened? Yeah? We were working so nicely together. So what we need to do is, this graph was moved 60 degrees to the right. So let's just touch here. If we move it 60 to the right, then you need to think logically now. You see, it was at 90 now. 60 to the right, this would be like, is it not like 150? This would be like 150. It was at 270, right? 60 to the right would be like at 330. And then this point here, I mean, like it was at 0, so now this would be at 60. This point was at -90, right? So this point would now be at -30. This was at -270, so it would now be at -210. This turning point was at -180, so it would now be at -120. So all that information, you can see the theory is helping us to get it, you see. So this point here would just be -120, coordinate -2. So that's what our P is. I mean, that's what our T coordinate is, -120, coordinate -2. We just finished the question good, you see, because remember, the turning point was initially at -180, but it was moved 60 to the right, as we have just identified. So carrying on now, we can work out this question here. We now know what P is. P is just -120. And they didn't say anything about not using a calculator. So guess what? We are going to use it. We are going to use that calculator. So let's see, -3 and then x over 2 there. So let's just write out the equations here. F of x is -3 sine x over 2. And then g of x is 2 cos x minus 60. Woo, what you got now? What you know about rolling down in the deep, blah, 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 blah. What's going on now, huh? So let's work out what f of -120 is, get an answer, and then also work out what, well, let's just do it simultaneously. Like, you know, why you have to be so, you know, broken up. Let's just do it together, you know, do it together, my guy. So for f, we're going to have -3 sine over 2. And then for G, we're going to have 2 cos negative 120 minus 60. Whew. Okay, so this, you may want to just put all of it in the calculator, like all at once. No need to like do any funny business. Nothing crazy, nothing the major. You're just going to throw all that in there. So if we're putting all this in the calculator, our calculator is giving us, okay, it's coming out as a third, whatever you might call it. So it's like 4 plus 3 square root of 3 over 2. But then you can just, round it off to 2 decimal places, which would just be like 4.60. That's the way. This just means approximately. And you can just use it usually when you like, round off a value. Whew, that was an okay question. You see, this is why your theory is important. And this is why things like the trigonometry course is 100% important. You see, you got to get it on the course website, and I'll give you a 50% discount code for the all access pass, EYB50. Now, this discount code applies for the all access pass, as mentioned, all access pass. There we go. Now, the idea is on the course website, right? I'm like, apart from just the online courses, the one-on-one Zoom sessions, right? If you're planning on like signing up for one-on-one Zoom sessions, then I mean, like on the website, there's like a once-off fee for one-on-one Zoom sessions for the entire year. Now, the one-on-one Zoom session fee for the entire year, it's just like 4,999. This gives you access to like everything on the website, all the online courses, the study guide, everything, and you'll have access to a one-on-one Zoom session every week for the entire year. So this is like a once-off fee for everything, for once-off for the whole year type of thing. So that's just that. But then the 50% discount code applies for the all access pass. This is the monthly fee for the all access pass, but then the once-off fee is like 2,999. To get that, you'll just, so if I go, for example, on 2,999 here, and I click on purchase, right? What you need to do to apply your discount code is the following. So you can check up here, it says view order summary. If I click down here, it says, do you have a coupon code? If you put in here BYB, I think it is, let's just, hey, come on, bro, come on, man, we want to see what we're writing down. BYB50, you see, I wrote there BYB50, even if it's small letters. Just click on apply there, and then bam, it chops off half the price here. So even if you chose, let's say, the monthly fee, right? As long as the discount code is applied, you're gonna see that it will still be cutting that amount in half. So for example, here you see the discount code is applied already. So UIB50, 50% off. That's how it's chopping this out. And you will be able to like put in your details. Or if you need to maybe just make a purchase via EFT, the EFT details, they are in the FAQ section, the frequently asked questions section. So down here you can see, hey, Bowman, scroll down, frequently asked question, can I make a payment via EFT? Yes, you can. These are the details, blah, blah, blah. Whew, okay, let us carry on now. Moving forward, it says here, for 3 marks, use the graphs to determine the values of x in the interval x is an element of negative 180 to 180, for which g of x is above 0. Okay. These kinds of questions, I mean, like you have to use the images. So if you have an image given to this question, excuse me, I burped. I don't know if that came out in the mic, but hey, shame, man. I don't know. It is what it is. I feel like Kung Fu Panda now. Okay, that escalated not well enough. But anyway, so with this question that we are trying to work out, you just need to use the image. This is just saying in the graph of G, right, where are the Y values smaller, bigger than 0? So the Y values are bigger than 0 up here. Like, it's so clear. This is the portion where the Y values are bigger than 0. You see, from this X value until this X value. So obviously we need to make use of our theory. So if you can remember this image, right, you can see the portion that we're seeing is this hump here. See? Because like, look nicely. Look, see? This hump here is this hump over there. You see, because remember we mentioned T is there, T is there. So according to our image here, we can see this is from -30 to +150. So those are the x values where it's above 0. So you're going to have to say x is an element of negative 30 until positive 150. So we're using round brackets because specifically at these points, the graphs are equal to 0, not above 0. So just after this point, it's going to be above 0, and then just before this point, it's going to be above 0. So they're going to give you 3 marks for that. And you see the 3 marks are coming from you knowing your theory. Because you knowing this is negative 30 and you knowing this is 150. I mean, like, that's pure theory that you need to know. And as mentioned, that's the kinds of things you learn in like the study guide, the online courses, etc. Okay, you can always just hit me up on IG if you need more clarity. So it says here, right, where is g of x multiplied by the first derivative bigger than 0? So with questions like these, right, I mean, again, it's all about understanding what your image looks like and what these symbols mean. So what you want to recognize is that, remember, this here means y values. This here means gradient, the end, you see. So they're asking this y, they're asking this expression, where will it be bigger than 0? Now, the one thing to take note of is before you even worry about gradient and y values or whatever, just remember that for an expression to be bigger than 0, if you're multiplying two things, for this left side to be bigger than 0, then you have to consider cases where both of these are positive or cases where both of them are negative values, you see. So if it's a plus times a plus, this will be bigger than 0. If it's a minus times a minus, it will also be bigger than 0. So in our graph of G, we have to figure out how do we know what, we just need to figure out, what these symbols mean. So we know that G refers to y values. So I mean, like, if you think of it nicely, we want cases where the y values are positive and other cases where the y values are negative. So to do that, let's just use our picture. So in our picture, we can see that these are all the y values that are negative. These here, the orange ones. Those are all y values that are negative. Same here. That's the part where the y values are a negative, you see. And then the part where the y values are a positive, it's just clearly this part here. This is the only part where the y values are positive. That's representing this part here. For gradient, remember, for you to determine whether gradient is a negative or whether gradient is a positive, it's quite simple. All you have to do is you have to almost pretend that you're riding a bike on this line. So if you're riding a bike on this line, a bicycle, here you're going to be going down the line. So any part where you're going down, that's where the gradient is a negative. So any part where you're going up, that's where the gradient is a positive. So from here going all the way up there, this is where the gradient is a positive, you see? And then once you reach the turning point, you would be going down again. So this is where the gradient would be a negative as well, you see? So the green, so for the green, that's the part where you have a negative gradient. And then the red is where you have a positive gradient, you see. So technically, if you look at our colors here, colors make the world go around. We want cases where you have blue and red together and cases where you have green and orange together. So if you look nicely at our sketch, right, here you have what you call orange and green together from this x value until this x value. You see, this x value, we know it's like negative 120. We worked it out. Negative 120. So this is going to be the first portion of our answer, because this would be negative gradient, or rather it would be negative y values multiplied by a negative gradient. So this will be an expression that is bigger than 0. So the first portion of your answer, you'll have to say that x is an element of negative 180 up until negative 120. So it's round brackets because specifically at this point, the gradient is equal to 0, not smaller than 0. So here we won't need to include the, what you may call, the negative 120. But I think the 180 we have to include it though, actually. The 180 we have to include it because specifically at 180, the gradient is a negative and the y value is a negative. But specifically at negative 120, the gradient is equal to a 0, not a value that is a negative. So that's the first portion of your answer. And then we also need to look for other cases where you have green and orange, you see. And that's like over here. You have some green there and some orange. So in terms of your answer here, you can see that this X value here, we worked it out to be 150. So from 150 to 180. So you're going to have to say here, X is an element of, specifically here, the Y value is equal to 0. So we have to exclude the 150 because we want it to be what you may call below 0, not equal to 0. So we have to exclude the 150 there. It's going to be from 150 until 180. The 180 we do have to include it. So that deals with the orange and the green there. So we want other cases where you have blue and red. So blue and red, we're getting that over here. You see blue and red, just this tiny part here. You have blue and red. So this part here, you can see this is from -30. And then this new turning point, we know this was like at 60, remember? Because if you look at our image, you see it was moved. It was firstly like at the Y axis, then we moved it 60 to the right. So the new turning point is at like +60. So this is at like +60 and then -30. So the other answer, we can say X is an element of, here it's specifically a 0, not anything that's like a positive. So here we have to exclude the -30. And then at 60, we also have to exclude the 60 because the gradient there is specifically a 0 and not like a positive number. Woo! So yeah, this is why you're going to get 4 whole marks for a question like this one, because you can see like a question like this is not like child's play. Like not at all, bro. Like not at all. Because this is where you like earn your stripes, you know. This is the kinds of questions that like show you if you know what you're doing. And you can imagine, right? This is why I keep advocating for the trigonometry course, because you're going to learn more and more of these kinds of things, you see. So, but if you do feel like maybe you need some a bit more convincing before you do join the online courses, I mean, like you could always check out like the main YouTube channel also, because in the main YouTube channel, right, Bright Young Brain, you have a playlist that works specifically on inequalities. I don't know why this thing is taking so long to load. Like, dang it, bruh. Like, why you gotta take so long? Like, really? Seriously? So, under playlists, right, on the channel, right, you're going to scroll down here. You're going to see there's Inequalities Grade 12. So, in this Inequalities Grade 12 playlist, it's basically going to like just give you a bit more examples on all these kinds of questions, you see. So, you can always check that out. But, anyways, moving on to the next question. Question number 7, we are here. We are within question 7. It's a 3D triangles question. In the trigonometry course on the website, the 3D triangles section is like chapter, I think it's the last chapter, chapter 5, because like this is like practically the last trigonometry stuff that you guys learn. So the link to that is in the description. It says here question 7. The captain of a boat at sea. Okay, the captain of a boat at sea. At point Q, okay, there's the captain. Could have made it at least a C, you know, C for captain, but oh well. So the captain of a boat at sea at point Q notices a lighthouse, which is PM. So PM is the lighthouse. And then after noticing this lighthouse, they say it here, notices a lighthouse PM directly north of his position. So directly north of his position. So it's like straight ahead. And then it says here, he determines that the angle of elevation of P, which is the top of the lighthouse from Q, is theta. So this angle here is theta. Remember, you have to, this is a 3D image. But let's carry on reading. It says here, and the height of the lighthouse is X meters. And then it says here, from point Q, the captain sails 12x meters in the direction beta degrees east of north of point R. No, east of north 2 point R. So this captain is sailing towards the lighthouse, but then he changes his trajectory. He's not going towards R, right? And then it says here, he notices that the angle of elevation of P is also theta. From R to P, the angle of elevation is also theta. And then he says that QM and R lie in the same horizontal plane. So QM and R lie in the same horizontal plane. So it means that QM and R are more like on the ground. This is like more like the sea. Because I mean, like, you know, this is like on the ground. And then from the ground, I mean, like you have the lighthouse going upwards. You see, that's why this angle is 90 degrees and that's why that angle is 90 degrees. Because remember, anything on the ground is always going to meet the ground at an angle of 90 degrees. So this is the ground here, or rather this is like the sea. And then here the lighthouse is going upwards, the lighthouse. So for these kinds of 3D triangles creations, right? Always keep in mind that even though you're not given actual lengths here, you're given X, you're given theta, you're given beta, always treat those as though it's like actual dimensions given. You see? The reason I'm saying it like that is because when you pick formulas to use, any side that has, you know, any form of expression, you should always consider it as almost like something specifically given. So for 2 marks here, they said write QM. Where is QM? Write QM in terms of X and theta. So this one is not so bad. So whatever they want you to do, right, always try and figure out which triangle it's in. So QM is in the triangle at the bottom or the triangle up here. So, I mean, like you could use, it looks like because you need to write it in terms of theta and X, it looks like the triangle here that's standing upright is the one you may want to use. So it is best to, you know, just do what's easy. Because if you're going to use the one at the bottom here, I mean, like you have a beta over there. And in whatever they're asking, they said nothing about the beta. So here, you know, this is theta, this is X. Now, because they want QM, always think of what do you have and what are they asking for. So if you look at it nicely, it's a right angle triangle. You technically have the adjacent. You're looking for the adjacent, but you're given the opposite. You see, you have the angle over there. So you're just going to use tan. So tan theta is got opposite over adjacent. See, opposite over adjacent. And then you can just isolate QM. So isolating QM, you can firstly just multiply by QM on both sides. Yo, good lord, when's in Johnny? Times by QM here, times by QM there, you're gonna have QM tan theta. And then to get QM on its own, you're gonna divide by tan theta on both sides. Divide this side by tan theta, and then divide this side by tan theta. That is the way I like it. So this is like X over tan theta, like that. And that's like 2 marks only. So yeah, is good. Is good, eh? Is good. So for 4 marks here, let's see. What does this mean now? It says prove that tan theta is equal to cos beta over 6. So I mean, like with the next question here, I mean, like you always have to look at what is in your sketch, you know, what is in your sketch, what have they asked you to work out? Because with math, right, like the funny thing is, oh snap, this thing is not showing. No, it's doing that thing again. Ah man. So the idea is with your questions, right, whatever they're going to ask you, always take note of what did they ask you before the question they're asking, because they won't just ask you random things for nothing. You know, 99% of the time, whatever they ask is because they want you to use it in like a follow-up question. Maybe not 99, but a good maybe like 80 or 90% of the time. So here we need to remember, what did we just work out? We worked out a length for QM. Let's actually put it here. For an expression for QM, it's just X over tan theta. So that's important. X over tan theta. Now they are asking for the expression tan. We should show that tan theta is equal to cos beta over 6. So for this kind of equation, you really should not overthink it, because I mean, the only triangle that has beta in it is the one down here. You might as well focus on the triangle down there. because the triangle down there, you now have QM. You know, so this one is more of a no-brainer also, because with 3D triangles, always work with one of them at a time, you know, one step at a time. So here, this is going to be like QM, this is R, and then this is like 12x, and then this is like x over 10 theta. See, like that. And then this is like beta, and then what else now? What do we need? We have an angle here, we have a side, and we have a side. And they're asking us to come up with this expression. So you don't need to overthink it. The fortunate thing is here you're just going to use the cosine, because the cosine rule requires you to have an angle in the middle and then two sides where that angle is, which is this side and this side. But then the only issue is the cosine rule here is probably not going to work, because wait, do we have RM? Do we have anything for RM? Nope, we don't have anything for RM. So we might as well hold on in terms of like thinking of the cosine rule, because if we incorporate the cosine rule, we have to put something for MR, of which right now we don't have that kind of ammunition, you know, we don't have that kind of information, you know what I'm saying? But then we kind of do, because look, if this is theta and this is theta and this is x, these two triangles here, they are, I mean, like we could say they are, it's more like the same thing, because wait a minute, hold on, I'm about to mess up here. Yeah, because if you're to work on MR is going to be the same as QM, because if you were to use this right angle triangle here, right? I mean, like here there's theta, and then here there's x. So MR, you know that this is adjacent, this is opposite over adjacent. So you'd have said tan theta is equal to opposite over adjacent. And then here, if you isolate MR, you can even do it a different way. Here, if you cross multiply, 1 times x is x, MR times tan theta is MR tan theta, and then MR is equal to x over tan theta. Okay, so yeah, I guess this was some quick thinking. So MR here, right, we're going to make it x over tan theta also. Yep, that is what this thing has come out as. Like we literally just showed it here, that MR is also just, you know, x over tan theta. Let me remove this part just so that we don't confuse anybody. And I might as well color code this the way it is. And let's make it all, you know, with the blue and stuff. Okay, fine. So we can use the cosine rule here, because we have something to put for every side and we have an angle to put in there. So we just have to write this nice and slow, you know, nice and slow. Nobody is rushing anywhere here. You know, this whole thing is, yeah, let's move this over there. Actually, maybe shrink this now. Hey, when I shrink, man, shrink. Why am I being so extra now? So this was here. Okay, yeah, so let's move on. Let's write out what we can write out. We just need to write out the cosine rule here. So as writing out the cosine rule, remember, the cosine rule says something like a squared is equal to b squared plus c squared minus 2bc cos a. This angle and this, this angle and this side will always be the angle that you have and the side opposite the angle. So if you can just throw these in there, your other information goes in the middle there, where the BC is, which is going to be this side and this side. So what I mean is here, let's actually just write it as MR squared. This is equal to MQ and RQ. So this is like MQ squared plus RQ squared minus 2 MQ RQ. The angle there is MQR. QR. Let's just throw in our information now, you know. So MR is just x over 10 theta. So this kind of does look a bit over Q. For how many marks? For 4 marks. Yeah, it does look over Q. Yeah, it really does, eh? But hey, it is what it is. It seems like it's going to work, so you might as well just use it. Now I'm thinking to myself, what if we had just used the nope, this is fine. Let's just carry on. Let's not be jajarach. Don't panic. Here we should not panic at all because it seems like we're doing okay, you know? X over 10 theta. And then RQ is like 12x squared though. And then MQ is like x over 10 theta. And then RQ is like 12x. And then cos the angle beta. So here you have to be careful. Like, just think slow. So here this and this look exactly the same. So if this goes to the left, we'd have a 0 there. And then 12x squared is going to be 144x squared. Nah. Ish. You see this whole 144 stuff? Ish. Yeah, it's not looking pretty. I don't want to lie. It's not looking pretty at all. So all this multiply together. Let's just keep in mind that if you're going to multiply a fraction with everything else that's not a fraction, always try to look at these as fractions as well, you know? As in, put this over 1, and then put also this over 1, you know? Because, hey, why not? You know, it also wants to be a fraction. So let's just put this over 1 also, so that you can just say the top gets multiplied together. So it's going to be 24x squared. The bottom, you're going to have 10 theta. And then you have cos b there. So let's move this whole thing to the left so that it comes out as a positive. 24x squared over 10 theta cos beta. So let's actually put the cos beta at the top because that's where it belongs, right? Yeah. And then this is got to 144x squared. Whew. Yeah, ne? Yeah. I was about to say Ziakala, but I'm like, what does that even mean? Hey, I'm not sure, so let me hold it. So we want to isolate 10 theta. So you might as well just make this a fraction as one, then cross multiply. Because it's the same as like getting an LCD, whatever. 10 theta times this is like 144x squared, 10 theta. 1 times this is like 24x squared cos b. Now it looks like we can divide both sides by 24 by 24x squared. 24x squared divided by 24x squared. So fortunately this all goes away. 144 divided by 24. I hope that's a 6, eh? I hope it is a 6. Ooh, it is a 6, ladies and gentlemen. It is a 6. So this is going to be cos b equal to 6 tan theta. And then because 1 tan theta on its own, we're just going to have tan theta here is equal to cos b over 6. Oh, that's the way. Oh, like it. That's the way. You can even write the cos theta first, then, you know, just for the vibe. If you left it like this, I mean, like, it's totally fine. But, you know, hey, just, you know, to be extra, you can just, you know, have it all swapped around and stuff. So it's all good. It's all good. It's all good. What's the thing now? Whoa, what am I saying? Oh yeah, everything is all good. Everything is all nice and dandy. So let us move the on. Let us move the on. For 3 marks here, they said if beta is this and QM is this, calculate the height of the lighthouse to the nearest meter. So we just need to work out X. And solving for X here, I mean, like, let's see what our image looks like. Let's see what our image looks like. Oh, we can just use, I mean, like, the first thing that we worked out, you know? Because like in the beginning, so now we have theta. Okay, but we have beta now. We have to, oh wait, we can use the triangle down here, I think. We can just work out the length of QR. Because, yeah, because if they've given us a beta, how does that, maybe, actually, let's see what we had to. So here they've given us beta and no, that's not going to help. Let's check, let's see what we have in the, I feel like it's an easy question, but I'm busy wasting time. So they've given us theta with, yeah, let's just use the triangle at the bottom. Because the triangle at the bottom is the one that has all these things that they are talking about. The triangle at the bottom let's look at it nicely now since we have values. So we have 12x here, because remember we just need to solve for x. So there's an x here, so we might as well, you know, just use the triangle at the bottom, because the triangle at the bottom has beta. Now the other thing is, remember we showed that QM is the same as MR, like we showed they're equal. So it means that this is also equal to beta. So we have two angles in our sketch. Let's actually just put actual values there. So this is gonna be 40, 40. And then here this was x over 10 theta. Oh yeah, so this is like x over 10 theta. Do we have theta? No, wait, no. I'm busy doing dumb stuff here. They gave us QM, bro. I'm not focused, man. You're not focused. They gave you QM, bro. I might as well just use this formula. But then they didn't give us theta. This is dumb. But we can work out theta. Yeah, I feel like I'm going in circles here, to be honest. Like, I really feel like I'm going in circles. Because, I mean, like, I feel like we need theta from here, and then let's just see. I feel like I should just calm down. But then because I'm not yet calm and I don't want to waste time, I might as well just do what is on the mind. So here, if you're going to isolate, what are you going to isolate? Let's isolate x. No, bruh. Wait a minute. What's going on here? Dude. Yeah. I'm sorry. My mind is distracted. I'm really sorry. We might as well use the previous sketch because the previous sketch has QM. Yeah, this is dumb. Yeah. This is 40. This is 40. This is 60. This is 60. And then there's 12x here. So it looks like, is the cosine rule going to help us? Maybe, yeah, let's just use the cosine rule again. Because in the cosine rule, yeah, it is what it is. In this cosine rule, yeah, I know exactly what we're supposed to be doing here, but for some odd reason, I am just flopping. So let's just use this formula again. I think it's gonna help us because we have three sides to put in there and an angle, and then x is going to be the only thing open. So let's use the same formula again. Copy, and then let's paste this thing here. Make this smaller-ish. Put this here. Do this like that. So if you put everything in this formula, MR, let me just label these things here. So you have M here, R there, Q here. So MR is like 60, right? So it's like 60 squared. MQ is like another 60. RQ is like 12x squared. And then MQ is like a 60. RQ is like a 12x. And then the angle you're dealing with is this one, right? It's just a 40. Yeah, so at this point in time, yeah, just keep calm. Like, you're technically home free, so you might as well. So this and this will go away because if you take it to one side, they cancel out. Then it's almost like the same thing as what we were doing earlier. So here it's 2 times 60 times the 12. What you're gonna get, 2 times the 60 times the 12, you're gonna get 1,100 and no 1,440, and then this is, and then here I forgot the x, and then cos 40. There we go. So the only issue here is factorizing. We have to factorize here. So it looks like I can take out 144 as 144x as a common factor. And then here I'm going to have x and then minus probably like 100. Yeah, no, 10, bro. 10. Come on now. Come on, bro. Focus, my guy, eh? Focus. So here it's going to be 144x is equal to 0. Or, but why do I feel like I'm making another error just as I'm fixing one? Yeah. I just need to be careful. Just need to look nicely. Right, let's just carry on. So this is going to be 0 is equal to x minus 10 cos 40. So x is equal to 10 cos 40. Let's see what that gives us in the calculator. 10 cos 40. Whew, okay, that's a bit more believable. X is like 7.66, which is approximately equal to 8 meters. That's the way. We like it. That's the way. We like it. Yeah, so with answers, right, always try and check the logic behind that answer. Like as we saw, 2 point something meters for a lighthouse. That doesn't make sense. A lighthouse needs to be like, long and tall and visible and stuff like that. So from afar, if it's only 2 meters something, yeah, it doesn't make sense. So let's see here. Let's move on to question 8. We are now in Euclidean geometry territory. So to be honest, I'm kind of, vibing with Euclidean geometry these days, like big time. It says in the diagram, right, O is the center of the circle. And then it says you have radii OH and OJ. I mean, OH and OJ are drawn. And then it says here a tangent is drawn from K. So you have a tangent from K here, right? Like this. And then, as all this information is being given, right? Always think of theorems, you have a tangent and a radius here. So automatically, you know that this is 90 degrees. And you know that since these are radii, you have angles that are equal to each other. And then since you have a tangent, you have the 10 chord theorem, things like that. Don't take them for granted, Otherwise, you shall cry. And crying is not good. But anyways, because remember the 10 chord theorem only applies if you have a full triangle and one point of that triangle is touching your tangent. You see, that's where you'll have the 10 chord theorem. Okay, moving on. So they say then here, a tangent is drawn from K to touch the circle at H, and then it says triangle HGJ. HGJ is drawn such that these are parallel to each other. So this is parallel to that. And then it says here O1 is 2x. So here you have, this is 2x, right? So automatically this is x because of your theorem that says that an angle at the center of the circle is double the angle at the circumference. The reason is they are subtended by the same chord. See, because you have a circle there, you have a center, the angle here, and then you have the one at the circumference over there. You see, so this is like 2x, like x. Whew, okay, so it seems like there's quite a lot of information. So they want 3 other angles equal to x. Well, we got one already, which is just G there. So angle G is equal to half of O1. The reason is angle at center of circle. You see, so as a conclusion, therefore G is equal to half of 2x, which is equal to x. So that's the first angle equal to x. Now what you want to do is once you find something equal to x, just use that to find the others. So the easiest one here, these are alternating angles here because of parallel lines. So we know that H1 is equal to x. H1 is equal to what you may call the G up there. So H1 is equal to G, which is equal to x. The reason is alternating angles. And then we want something equal to H1. H1 is equal to angle, this is J, right? Yeah. H1 is equal to J, which is also equal to x then. And then the reason there is 10 chord theorem. You see? 3 angles equal to x. Very simple. Not a mess at all. Very nicely. So we keep moving forward. They want us to prove that H2 is equal to H3. H2 equal to H3. So that's quite interesting. How many marks? So you see here, this is more like an automatic question. And it literally was like that in my head. The moment they ask for us to prove that H2 is equal to H1, I automatically ask myself, what is the mark allocation, because the moment you ask yourself how many marks, it helps your brain to like figure out how much you should think and all that. You see, it literally just helps your brain to figure out how much you should think. So for example here, let's just put out what we know. X is equal to this, and this whole thing is equal to X. What we also know is that these are equal, and then they want us to prove that H2 is equal to H3. So if you're gonna prove that these are equal, try not to focus too much on them individually, because I'm like, look at them, especially H2. H2 is in a very weird spot. Let's focus on H3 for now. So knowing that these are radii, we know that H3 is gonna be equal to 180 minus the 2x, the whole thing divided by 2. The reason for that is angles opposite equal sides, because that's an isosceles triangle. This shape is an isosceles triangle. So let's get a length for H3. So this is giving us 90 minus x. So we have H3. Fortunately, we know that this is also a 90-degree angle because of tangent perpendicular radius. So let's tell them that OH is perpendicular to KH. The reason is tangent perpendicular radius. So the whole thing here is 90. So automatically H2 is going to be equal to 90 minus H1, which is going to be 90 minus x. You see? Therefore, H2 is equal to H3. So if you want to write down a reason for this, I mean, it's proven. You proved that this tiny part is x. So you can just write here proven, because you proved that this whole thing here is, this tiny part is x. And you showed that the whole thing is 90. So you can just write 90 minus x here, proven, because you proved that the tiny part there, which is h, is equal to x. Okay, 3 easy marks there, nothing crazy, nothing major. So I think, yeah, that is that for this 8.1.2. Let us move on. Okay, 8.2. So for 8.2, right, it says here in the diagram, KLMN is a cyclic quadrilateral. Oh, so you see what I did there, right? You don't want to do that. You want to read and check with your sketch what you're reading. It says KLMN is a cyclic quadrilateral because all sides here are touching the circle. And then it says here KLM is 87, so that's fine. And then it says here diagonals LN. Where's LN? LN is here, and then there is MK over there. Okay, yeah. So I mean, like, things like that, don't take it for granted, because I'm like, here you have, theorems like, angles subtended by the same chord that are going to be equal. So you already know things like this is equal to that, and then a bunch of other stuff like this is equal to that. Like, as long as lines are crossing each other like this, you have so many angles here that are going to be equal to each other. If needs be, you can just, make use of that information. Let me actually remove this because it's going to be too much. It then says here, P is a point on the circle. Where's P? P is a point on the circle, and MP is produced to T, a point outside the circle. So this is not a tangent, you see, because it's like cutting the circle twice. And then it says here chord LP. Where's LP? LP is then just the line that they drew there. And then they said LMK is Y. This is Y. This is 2Y. Okay, that's interesting. So that's what they've told us. This is Y, and then N1 is 2Y. So for 2 marks, they want us to give a reason. Name giving a reason another angle equal to Y. Well, that's kind of easy, you see. Because remember, Y is subtended by LK. Another angle subtended by LK is N2, because those are angles subtended by the same chord. You see. So here, or angles in the same segment, whichever reason you want to say. So here we can say that N2 is equal to M, which is also then equal to Y. The reason is angles in the same segment. Angles in the same segment. You see, there you go. Angles in the same segment. So with this being said, I mean, like, you might as well label this Y, and then you can just carry on with your question. So what else? Let me just remove this so that it's not like too overbearing. You know, we don't want it to be too overbearing. Too overbearing is not good. So let's see. What else does this now? Calculate giving reasons the size of Y. So they want us to give the actual size now. You're nah. Okay, so here, yeah, it's not so bad because this whole thing is 3Y. N1 and 2, and the whole of N is 3Y. You see, N is equal to 3Y. That's been proven already because we've proved that that one side is Y. This is 2Y, it's given. So what we also know is with cyclic quads, right, opposite angles add up to 180. So N plus MLK, let's put that, MLK plus, M what? Yeah, MLK. If you add N, these should equal to 180 degrees. The reason is opposite angles of the cyclic quadrant. So with that being known, you know that now this is going to be 87 plus 3y. This is equal to 180. And then everything that does not have y can go on this side. And then you can just divide by 3 on both sides. You see, divide by 3 here, divide by 3. So y is 180 minus 87 divided by 3. So that's quite okay, it's not that interesting. It's just like knowing your theory, you know. So normally if you know your work, if you know your theory, if you know your theorems, you're going to have a party, man. You're going to have a party. You're going to be a partier. That's just reminding me of this meme. Yeah, but anyways, let's see. Let's move on. 2 marks. TPL, they want the angle TPL. Where's TPL now? TPL. Okay, that just escalated so fast. Like so fast, it's almost scary. So the idea is, I mean, like you do have at least all the angles. Okay, no, you don't have all the angles. What am I saying? You have like Y. So I think that should be useful in a way, like seriously. Now I think it's useful me. Hey, this thing keeps showing out blank. I don't know what's going on, man. Like it's so annoying. But anyways, let's put information here that we know. Because if Y is equal to 31, we might as well make use of that information. Because this one is going to be 62, 31. This one is 31. Like, let's not take that for granted. So, well, the fortunate thing is, look at this. This is a cyclic quad. They didn't tell us it's a cyclic quad, but we can see it's a cyclic quad, you know. So don't sleep on yourself. This shape here is a cyclic quadrilateral. This is 62, so this side here is going to be 180 minus 62. So LPM plus N1, LPM, let me see here, LPM, which is this angle there, if you add N1, it should equal 180. So let's write that down. We add M1, that should equal 180. The reason is opposite angles of a cyclic quad. So if you're gonna add these two, you're gonna have your wait, is it N1, bro? Come on, bro. N1. Why you gotta be so messy, man? It's N1. N1, we know it's 62. So let's just put that information in our what you call formula. So what you now have here is just LPM, got 180 minus 62. And then you have the, what's that answer now? LPM. What is 180 minus 62? 180 minus 62. This is like 118. 118. So the reason why this is important to us is because, I mean, like, look, angles on a straight line. We're gonna get this angle there. So the P that they want here, the TPL plus 118 should give us 180 degrees. TPL, which is what they're asking for here. TPL TPL plus the 118. This is 180 degrees. The reason is angles on a straight line. Angles on a straight line. So you see these formulas and theorems and everything, they will come flying in your head as long as you know your work, you see. So here, this is going to be 180. I didn't even have to do that. I could have just said exterior angle for cyclic quadrilateral. Let's actually go that route because it's faster. It shows that you know your work better. I mean, like, you could have done this also. Let me just get on here and like, hi, this is dumb. TPL. But then, I mean, like, different ways to like do the same thing, you know. So here you could have also then just said, as soon as you got this 62 here, I don't even know why I did everything. How many marks were they offering for this question? And like 2 marks only, you see? So for 2 marks, I would say all this was really just overkill. So, I mean, just for the sake of this question, I'm just gonna scrape everything, right? And then I'm literally just gonna say here, N1 is equal to 62, right? Proven. So now we can just say TPL is equal to N1, which is equal to 62. The reason is exterior angle of a cyclic quad. But I mean, like, me scraping what we just did, it's not to say it's wrong. I'm just saying for 2 marks, you probably would have done that. But if you did the long dry, it's still fine. You'd still just get all your marks. I just wanted to showcase that, you know what? Different strokes for different folks. So what you see first, you can always just go for that. I should have just seen it the moment I drew the cyclic quad. But it's okay. It's okay. Let us move on with this paper. Let's move on to question number 9. Whew. So for question 9, right, this is basically just a proof. Now this proof, they like it way too much. Now you really don't want to struggle with this kind of a proof, and here's why. So for 5 marks, they said use the diagram to prove the theorem which states that a line drawn parallel to one side of your triangle. So a line drawn parallel to one side of your triangle divides the other 2 sides proportionally. That is proof that xk, you need to prove that xk over ky is equal to xl over lz. This theorem is not so bad because you just have to be able to remember what you need to construct and all that. So in terms of knowing what you need to construct, it's super simple. What you need to do is you need to construct 4 lines actually. So let's write them down here. Construct. You have to construct. Let's name this. Don't know what variable we're gonna use now. A, B. Let's say construct A perpendicular to LX. Construct A perpendicular to LX. That's the first thing. And then you also then want to construct B perpendicular to the other line here. You want to construct B perpendicular to XK. You see? There we go. And then you also then want to construct LX and you then want to construct LY. Let me write here construct LY. So you want to construct this line over here, and then you need to construct KZ. Yep, yeah. But no, I don't think you have to construct these other ones here. I feel like the other ones, they're just going to make your life a bit difficult. No. Do we have to construct them? Like, I feel like the other lines, yeah, you cannot bypass not constructing these lines. It's just how it is. So I also have to construct KZ. I feel like these constructions on their own, at least 2 marks, you know? So with all these constructions being made, you need to focus and you need to know why. So the reason we've constructed the green line is because you want to work with the triangle at the top here. The triangle at the top here, you want to, or rather, let me color code it. Let me color code it. When we drew LY, we are actually forming this triangle. And then when we drew KZ, we are actually forming this triangle, you see. And we're going to talk about each of them individually. So for the small triangle at the top, let me not maybe make this green for now because it's going to be a bit confusing, you know. Let's just, so you have this tiny triangle at the top here, right? This small triangle at the top here, it's X, K, and L. Now, with, for example, the green dotted line, which is B, you are looking at this as your perpendicular height. And then you're looking at LX as the base. Base, this one is height. You see? And then if you're looking at this pink triangle again, let's draw it again like here. You're gonna have X, K, and L. If you're looking at the yellow line that we drew, right, you're looking at this as the height now. So this is the height, and then you're looking at LX as the base. You see? Now, for the two triangles at the bottom here, when you drew this line here and you drew that other line, the idea is on the left side of the image, you see you have KL there. And then you have this going on. Let me actually do this a bit better because this is where things get important, you see. Because you have this shape now here. There is KL, and then there is the other point here. This is Y. So the idea is, you see this line here extends going like this. You see, it goes up to X here, you know. But before it reaches X, we have the perpendicular height here. Let me just do this thing. Because I'm trying to make you understand without me just going through the proof, you see, because us just going through the proof, it's not going to help you. The more you understand why we're making these lines and everything, you'll understand better. So this line goes up to X, right? But then before it reaches X, your perpendicular height of this triangle here is this one, which is A. No, B. Sorry. The green is B. You see, this is the perpendicular height, and then this is going to be your base for this triangle here. For this shape, it's a similar idea. If you're looking at the pink, you're going to have KL again here. And then somewhere down here, you have Z. And then you have this triangle, right? You see? So the idea is with this triangle here, the same idea is playing out. Let me just do this, move this down here a bit lower, because this is important. So for this triangle here, which is this one, KLZ, remember this line is also going all the way until X. This is going all the way up until X here also. You see, but before it reaches X there, we know that we have this line here as the perpendicular height, you see, which is the A. You see, this is your perpendicular height. And then here, this is what you're looking at as your base. So we technically have 4 different triangles, because those 4 different triangles is where this ratio is going to come out from, you see. So this is how you do it. In this first triangle there, let's just label it, you know. We're gonna do triangle 1. Okay, let's not do anything else. Let's just try and see that. You see, the reason why we've made those constructions is mainly so that we have these 4 triangles. So what you want to do is these triangles that have the same perpendicular height, you use them together. These ones that have the same perpendicular height, you also want to use them together. So let us do it. So what you're going to write out here is you're going to write out area of triangle, this one here. So in the area of this triangle here, you can name it XKL, area of triangle XKL over the area of the triangle down here. The triangle down here, you can name it KYL. KYL. So this area over this area is going to be equal to the area of XKL also. Yeah, hold on. Area triangle XKL over the area of this triangle down here. This triangle down here, you can name it LZK. You see, and the reason for you writing out this equation is purely because of the fact that the way your sketch is laid out, right? You having your sketch laid out like this, as long as this line is parallel to this line, this is something you can always like write out whenever you're proving this theorem. You're going to write out this whole formula here with these areas, right, of the triangles that you're dealing with. And then after writing out what you would have written out, the reason for writing this out is going to be what you may call, it's purely based on the fact that you have triangles that are in between parallel lines. You see, as long as you have triangles that are in between parallel lines, it basically just means that you're able to write out that these two areas are equal to each other. You see, so you can even you don't even necessarily have to even have a reason for writing this out. It's just weird, but because people are obsessed with reasons, as we should be, we can just write here areas, triangles between parallel lines. Let me just write the word parallel. So the funny thing is, in some memos, right, or in most of them, they don't even give a reason for writing out this formula. But then this formula is everything that we need, because we now just have to put dimensions in that formula. So for this, if we're going to use this side of the image, right, the area of triangle XLK is going to be a half. The base is B. It's half base times height. This is it's going to be a half. The base is XK, and then the base is B, right? Then this area here, its area, we're going to say a half multiplied by the base, which is KY. What are you doing, bro? Just write KY. KY half base times the perpendicular height, which is a B. For these two areas, you would use these two triangles, right? Meaning that if you're going to write out the area of XKL here, you're going to say it's going to be a half. The base, you already know it's like XL. The perpendicular height, you know it's like the A there. And then you know that the triangle down here, its area it's gonna be a half. The base is just LZ, and then the perpendicular height is just A there. You see, and then from here, half cancels half, B cancels B, half cancels half, A cancels A. And then you can say therefore, XK over KY is equal to LX over LZ, which is what they want you to prove up here. You see, XK over KY is equal to LX over LZ. You see, it's all based on your constructions and why you are making those constructions. Because as long as as long as you make your constructions properly, and as long as you know why you're writing what you're writing, you're gonna be in a good spot. So that's that for this kind of a proof. Nothing crazy, nothing major, and it just makes your life so much easier. So yeah, man. So L Y K blah 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 blah. What am I saying? Yeah, I mean, like with these kinds of what you call questions. So here you said triangles between parallel lines, right? There's a reason for writing out the above statement. So you can just then state what those parallel lines are. KL parallel to YZ. Yeah. So as long as you have all this going on for you, I mean, you're good to go. Let us just carry on with the question paper. For 9.2, right? It says here, it's a 5-mark question, right? So we need to be, I mean, it's a lot of marks all at once. So that's what we should be seeing. So the idea is we kind of definitely have a sketch here where the whole proportionality theorem is going on, because there's a line in the middle here. It is parallel to the third side of the triangle.
Yeah.
So as long as we know that, let's see, it says here in triangle RST, F is a point on RS, and then H is a point on RT, and then it says here such that FH is parallel to ST. And then it says here RF is 2x minus 10, FS is 9, RH is 4, HT is x minus 20. So they say determine giving reasons the size of x. So this one is going to be quite straightforward because of our proportionality theorem, you see. So for this one, I mean, like you can just write out a ratio. This over this is equal to that over that.
And then you make an equation, right?
Yeah, 100%. So here we're going to say RF over FS is equal to RH over HT over HT. The reason is proportionality theorem. And then you can add the FH is parallel to ST, just for the vibes. And then with that being said, I mean, like now you can throw in your information and then just solve for x. So for RF here, it's like 2x minus 10. FS is 9. RH is a 4. HT is x minus 2. And then from that, you're going to cross multiply. Yeah, definitely. 9 times the 4 is going to be what? 36. And then here, this is where we have to be careful, because if you don't use brackets here, this is where things, start to go south. So here, 2x times the x gives us 2x squared minus 4x minus 10x plus 20. Whoa. Oh yeah, plus 20. And then if you simplify this, it's going to be like 2x squared. This is minus 14x. 20 minus the 36 gives us a minus 16. And then here we might as well just use the quadratic formula. I mean, some people would want to take out the 2 as a common factor first, but that's not really, you don't have to, like, we really don't have to. It's a choice, basically. So here x is going to be minus b. You can already put this in the calculator, I guess. So this is like, I need to make space. Zoop. Minus b. It's like b squared minus 4. A is a 2. And then c is a negative 16 over 2a. So what do we get over there? Check the calculator. And then you can be checking what it is that you're checking on your side. So in the calculator, it is giving us 8 or negative 1. So x is equal to 8 or x is equal to negative 1. But we have to disregard the negative 1 because we're dealing with distance here. So x is 8. So this is like quite easy. What you may call easy 5 marks, like very simple 5 marks. Yeah. So let's see here. Let's see the next one. For the next one is out of 4. So I guess this one is going to be a bit interesting. Let's actually maybe get this image just so that we are. I hope it doesn't do that thing where it pastes a blank. Oh, thank goodness. Okay, so we have here a sketch, right? But then the fortunate thing is, let's actually give our sketch dimensions, because like we earned it, you know? So this is 8, we got AX as 8, right? So this is gonna be 16 minus 10. What is, let me just try and make this, I'm just gonna give our sketch dimension. So this is like gonna be 8 times 2, right? Which is 16. 16
Yeah.
minus 10 is a 6.
6.
So this
Mhm.
length here is 6. Put a 6 over there. And then here this is gonna be 8 minus 2. So that's also a 6. I guess this is just a coincidence, you know?
Yeah.
Oh yeah. Let's just put a 6 over there as well. Let's put a 6, put a 6, and then we shall start. So they want us to get the ratio of the area RFH. Let's see what RFH is first. RFH. Okay.
Mhm.
And RST. RST. Oh, RST is the big one.
Yeah.
Okay. So, I mean, like, this is quite an interesting question. We kind of obviously need to be a bit strategic about it, because whatever we're gonna work out, we need to know what we're doing. So the funny thing is, we could be thinking to ourselves, I mean, are we going to use the area formulas? Are we going to manufacture something interesting, or what?
I think
So
it would be the formula of a half, times the RA times the RH times sin. That one.
yeah, definitely. So I think the formula we have to use is this one: half A times B sine C angle C.
Yeah.
So the fortunate thing is, with both of our triangles, let's do the small one first. The small one has angle R here, F and H. And then there's a 6 and a 4 and the angle here. Even though it's not given, let's just use that. And then for the big one, we also have that same angle here. However, in terms of dimensions, we have 9 plus the 6, which is like a 15, 4 plus the 6, which is a 10. And we also have angle R. So we can just use our area rule for this. So it means here, our area for the small triangle is a half. The two sides that we have, it's 6 times 4. And then the angle that we have is R. That's the one at the top. The one at the bottom is just a half. The whole thing is 15 there and 10. Also sine R. And unfortunately, these go away.
Yeah.
And then you have 6 times the 4 there. I think it's like 24. 150. Let's see what the calculator can give us. There we go. 4 over 25.
Yeah.
Yeah, so this one is quite interesting, because I think unless a person is bumped into these kinds of questions, it's gonna be a bit, yeah, a bit of a tricky situation. Not too tricky though. I mean, it's out of 4. I think the idea is noticing that we have a common angle over there. So as long as we have a common angle over there, we are good
Yeah.
to go. Yeah,
Definitely.
yeah. Okay, so looks like we have another interesting Euclidean geometry question here. It's definitely going to work with proportionality stuff for sure. But this is out of 5. So funny enough, let's just see here. It says out of, for question 10, right? It says in the diagram, FBOE. Let's see what that is. FBOE. Okay, this is the diameter of the circle with center O. And then it says chord EC. EC produced meets line AB at A. So the key thing we should not forget is these kinds of things here. They've told us that these are equal. So automatically this is a 90-degree angle, because a line from the center, if it cuts a chord in half, it means it cuts the chord at an angle of 90 degrees. Right? Yeah.
Right.
So it says here, D is the midpoint of EC, yes. And then it says OD and FC. OD and FC are drawn. And then they said here AFBC. So AFBC is a cyclic quad. So this is very important. AF, B, and C. They say that's a cyclic quadrilateral. Now, that's very significant, because if they told us that this shape is a cyclic quad, you have to pay attention to how these 4 points here, they are going to, they're doing some funny zigzag thing here. So you have angles that are equal to each other because this is a cyclic quad. It's not in a circle, but they told you it's a cyclic quad. As long as they have told you this is a cyclic quad, it means you have angles in the same segment, meaning this angle is equal to that one. And then it means that this angle is equal to that one, because angles in the same segment. So we should not forget that. We might also highlight that because it looks like we will need it. Cool.
Cool.
Okay, so now they say that we should prove that FC is parallel to OD. So this one, what do you think we can do to prove that FC, which is this line here, is parallel to OD?
So you can use your triangle EFC and EOD.
EFC and EOD, yes. They both have 90-degree angles there.
Yeah.
Because, yeah, for C1, we're going to say it's equal to 90 because angle subtended by the diameter of a circle. So that one is straightforward. We have to also tell them that D1 is equal to 90. So D1 is 90 because line from center bisects chord. I have to write chord better here. So we've just shown them that they're both equal to 90. So now we can say, therefore, D1 is equal to D1. See, we've just proven it. So because they're equal, we can then say, therefore, FC is parallel to OD because C1 and D1 are equal corresponding angles.
Levi, when you give me a triangle like this, would I have to prove that they're similar first, then prove that they're parallel?
Nope.
Or,
no.
Okay.
Yeah, because with similarity, that would be for something else. For this case, we just want a single angle. One angle equal to one angle, specifically here where they are corresponding, so that we can show that these lines are parallel.
Okay.
Yeah, similarity is probably maybe even in a follow-up question or something, like it's just, yeah, not too far-fetched.
Okay.
Cool. So with the sketch that we have, right, let's not forget our whole zigzag action here, because this zigzag action is something we should not forget at all, because as long as they've told you that this is a cyclic quadrilateral, trust me, it's something to not forget, because they will definitely punish people that will forget that. Anyways, for 4 marks, what is this question asking? For 4 marks here, right? Whoa, oopsie. Let me just highlight this. This is so for 4 marks, they said just put 4 marks there. Okay, that's not much better, but meh. They said we should prove, giving reasons, that angle DOE, so where's DOE? DOE, which is this angle, we should prove that it is equal to BAE. BAE, which is this angle there. So for 4 marks, I mean, like you can imagine, you're not gonna just jump from here to there with a single theorem, right? So what do you think we can do to show that this angle is equal to that one?
Well, to show that it's equal, can't you prove the triangles are similar?
Yeah, I mean, you are busy. Yeah, I feel like similarity is something that's
Well,
like
you
stuck in your head.
Well, the sides are parallel, so
Yeah,
so
so this is parallel.
the one thing I can say though is that E is common. So
Well, okay, so let me put it this way. Remember, you're trying to just show that angles are equal here. The easiest way to show that angles are equal is focus on those individual angles and find what they are individually equal to. For example, what angle is equal to A that you can see?
F.
Yes, that's where you start. So this BAE they speak of, it's equal to F. And what's the reason?
Angles in the same segment.
Yeah, angles in the same segment. And we're only saying this because they told us that it's a cyclic quadrilateral. It was told. If they had not told us, we could not have said that. So now what you just need to do is what angle is equal to DOE?
DOE. Well, D1 equals C1.
Well, yeah, but then we want an angle equal to this one, the pink one.
The corresponding. No, yeah. F
Yes.
and O.
Yes, exactly. Yeah, it's also equal to F. So DOE is also equal to F. The reason is corresponding angles.
Yeah.
Corresponding angles. You see? You have shown that the two angles that you're supposed to show are equal. You have shown that they're equal to one thing specifically, which is the goal or the way to show that two angles are equal. Don't focus too much on things that are like too crazy, like similarity and yeah, that gets a bit crazy, you see. So here all we had to do was find something equal to this on its own, find something equal to this on its own, and then you will normally see that they are equal to the same thing. So here, therefore, BAE is equal to DOE. See, proven. Because this is going to be mark statement, statement reason. So that's good enough for 4 marks because you've shown that they're both equal to F. So we keep moving forward.
Yeah.
Whoa, I feel like I skipped the question. No, I didn't. 10.1.2 and then 10.1.3. Well, it's a 7-mark question. It's just any 7-mark question needs you to do something first and then something afterwards, like basically. So this is literally just an expression that would look like AB.OF equal to AE.OD. This should remind you of proportionality theorem, right?
Yeah.
Yeah, should remind us of similarity as well. Should remind us of similarity. That's important. You see, never take stuff like this for granted. So I mean, like in our sketch here, now we could be thinking of, similarity and all that, because like, I mean, the question we are asked, it almost warrants that kind of thinking, you see, because if we're seeing what they're asking here, like it's so much in our faces. Let's see what lines they're talking about here before we even start. We just want to focus on what lines they're referring to. Once we figure out what lines they're referring to, then we can figure out which triangles to deal with. So they're talking about AB. AB is this long line here.
Yeah.
So while we're focusing on these specific lines, also specifically focus on lines that are equal to each other. So that's AB here. The next one is OE. Where is OE? I mean OF. Let me just try and make sure I wrote it properly. Well, why do I feel like I had written over the question. So I was like, where is that question now? Yeah, so anyways, let me just redraw this line here. So they spoke of AB, right? Which is this long line over here. And then they spoke of OF. OF is, so interestingly, do you see that OF just seems like a strange line?
Yeah.
Yeah, because it's just like there. But then the one thing to take note of is, remember we said pay attention to other sides that are equal to the ones they are talking about. So FO or OF is the same as OE, because those are radii, you know.
Yeah.
So as they are speaking of OF, always be thinking of EO as well, you know, because the lines that they're referring to here, you need to draw a triangle with each of them, or you need to draw a triangle with at least a set of them, and then a triangle with another set. So here now they're speaking of AE. Let's look where AE is. AE is, then you see this big line here. You see it?
Yeah.
Yeah. So I mean, like, before we even carry on, the moment we see that they're talking about this big triangle here, I mean this big line AB and this big line AE, automatically start thinking of a triangle that has those two lines in it, because there's AB here and then there's AE over there. You might as well focus on this triangle already. You see?
Definitely.
Yeah. And then here they spoke of what do they speak of next here? They speak of OD. So if you look at OD, it's this line over there. You see it?
Yeah.
Yeah, which is definitely, like, you know, just a strange line over there. But then remember we said the moment they spoke of of FO or OF, we would need to think of OE. So if we're thinking of this line that they spoke of, and if we're thinking of this line that they spoke of, it's easier for us to just focus on a triangle that has at least maybe this line in it.
Yeah.
Like that. You see, because the OE on its own there is just too random. It doesn't look like it's gonna serve us any good.
Yeah.
Yeah. So the other thing now is, I mean, like, in as much as all this is all nice and dandy, I mean, like, yeah, like the way our shape is laid out, or the way our two triangles are laid out, it looks a bit crazy. The reason why I say it looks a bit crazy is because, I mean, like, this triangle, this orange one here, it has a right angle triangle there. But then this big one here, I mean, like, it definitely has no right angle triangle anyway. You see, because like us proving that this is a 90-degree angle. Yeah, we might not need to prove that it's a 90-degree angle. We might just need to what you may call, we might just need to not worry about how this is 90. All we need to worry about is how we have identified that this is a triangle we're dealing with, and we've also identified that this is a triangle we may have to be dealing with as well. You see? Yeah. So even though this is 90, I mean, like, it doesn't matter. This could also easily be 90. You know, we don't even have to see it with our eyes. It just has to come out like that when we're working with whatever we're going to work with. Because with similarity, you have to beforehand already be able to see what's going to go together. And the one way to do it is also try and make use of what we have proven here. Remember, in the previous question, they literally just asked us to prove that this angle was equal to this whole one. So that's already one piece of information we can use. This angle, we have already proven that it is equal to this big one. So meaning in our two pictures, we already know which two angles are equal to each other. This one, which is that one, we know it's equal to that one.
Yeah.
And then we already can see that E is a common angle.
Yeah.
You see? So everything is almost solved for us here, even though it's a 7-mark question. So automatically we now know that if this is 90, this one is going to have to be 90 as well. Do you see it?
Yeah.
Yeah. So we just have to take things slow, you know, one at a time, and then we'll be done. So we don't even have to focus on the 91. We can just focus on the green, on the yellow and blue sides, angles. And then the third ones, we'll just say they're equal because of interior angles of a triangle. So the 7 marks are literally coming from us identifying which triangles to work with, because you can see that's all really what we have to do here. We just have to see which 2 triangles do we need to work with. So here we saw that we're working in this triangle and this one. So naming them, we can name them, let's say in triangle, let's name it ABE, ABE, and this one will have to name it ODE. You see? Yeah. So once we have seen which triangles we're talking about, right, we can now just work in them and do what we want to do. We can just show the 2 pairs of angles that are equal, and then the third ones will just say interior angles of a triangle. So in these 2 triangles, we can just say E is equal to E, common angle. Yeah. And then A is equal to the DOE there. That's proven. Right. And then lastly, we can then say, therefore, ODE is equal to ABE because of interior angles of a triangle. So now, because we have shown that all these angles are equal, we can now say that this is similar. Therefore, triangle AEE is similar to triangle ODE. Because we've written that, now we can do our whole proportionality stuff. Therefore, AB over OD is equal to E over DE, which is also equal to AE over OE. Now we're almost home free, because all we have to do now is we have to find out, okay, fine, from the question they were asking us, which of these lines do we have in our expression? And then we just have to target. But before we finish here, let's just give a reason. The reason here is just proportionality theorem. You see?
Yeah. And then
just a
Diva,
proportionality theorem.
Wouldn't that OE change to OF because of equal?
Yeah, that's exactly where we're going with this next step that we're going to execute. Because the next step now, we have to just go through these lines and then pinpoint them out here. Like here we have AB, right? So we have AB there. Then we have OF. We already identified that if we're talking about OF, let's just choose OE. So this is good enough. Then we have AE there. So there's AE here, and then there's OD. There's OD there. You see? So now you can just take these 2 together. AB over OD is equal to AE over OE. So from here, you can just say OE is equal to OF because they are radii. You see? So that you can say, therefore, AB over OD is equal to AE over OF. And then to end up with what we have here, you can just cross multiply. You see, this times that gives us AB times OF. This times this gives us AE times OD. AE times OD. Then you're done. 7 whole marks. Yeah. So we can see why it is important for us to be able to identify triangles to be similar, or which ones are similar. And we saw how with the lines that they gave us, what we mentioned in the beginning about taking note of lines that are equal to each other, that's like super important, and we saw that we just need to be able to draw some kind of a triangle with the lines that they gave us. So for that one, they gave us this one and this one, but we used this too. This was the only feasible triangle. And then for the long AB and the long AE, this one was the only feasible triangle. Okay. And then that's how we did it. Cool. Yeah. So I think we might as well do this last question while we're still in the zone. Because, yeah, let's hope it's not too crazy. Because, hey, when you're feeling too confident, that's when things like form out. But let's see for this 5-mark question what we can do. We just have to be a bit careful. So for this 5-mark question, yeah, I don't even know I'm reacting the way I'm reacting because I feel like I really shouldn't have reacted like that. Because reacting like that is not so good, you know. Yeah, it's not the best way to react. But then I mean, like it is what it is, you know. We just have to do what we have to do.
Yeah.
So with a question like this one, we kind of really have to have an open mind, you know. So in terms of us having an open mind, let's see what they are telling us. And we should not forget what we have just worked out. Because the moment we forget what we have just worked out, yeah, it becomes a bit of a problem, you know. But what we have just worked out might not even be useful to us, you know. We might as well almost, we don't want to cling too much to it because this is a completely different question, 10.2. It's not like 10.1.4 or something, you see.
Yeah.
It's starting off as 10.2. So always to also take note of things like that. Because normally if you have, let's say, something like 10.1.1 and 10.1.2 and 10.1.3, they're trying to tell you that they have a link. But then the moment it's like a new question, like, yeah, you might as well start yourself to think to yourself, okay, it's a brand new question for 5 marks here. Cool.
Yeah.
Yeah.
Cool.
So they say it here, given that AT is equal to 3TO. So where is AT now? AT is this line.
Yeah.
Whoa. Interesting. Is equal to 3TO. So as long as AT is equal to 3TO, we want to think of this as a ratio. Meaning if you divide both sides by TO, you're going to have AT over TO is equal to 3 over 1. Okay. So AT is 3 times TO. So TO is the next part here.
Yeah.
Yeah. And then let us not forget that these lines are parallel to each other. These ones.
Yeah. Can't forget that.
Yeah. So we already have a ratio here. AT to TO is just 3 to 1. So meaning here we can put like a 3x here and a 1x over there. Because it's a ratio.
Yeah.
You see? Yeah.
Yeah.
And then let's just remind ourselves that these are parallel. Secondly, they said, prove that 5 CE, where's CE? CE is this whole thing here. Okay, that's interesting. 5 CE. So, I mean, like the other thing is, as long as they're talking about CE here, we need to remember that CE is just double CD, you know, so that we don't think too far away from what we have just seen here. So we should prove that 5 CE squared is equal to BE. Whew, okay, that one just kind of like, yeah, it just added something into our image. Is equal to 2BE multiplied by FE. FE is the whole line there. The whole thing. Yeah. So, I mean, like, to be honest, this kind of just makes our life a bit weird. You know? I mean, like, for lack of a better word, it really just does make things a bit crazy. But you don't want to take for granted how this is literally the last question in the paper. It means that this is the kind of a question you don't want to budge on working on this. You don't even want to worry about this unless you're done with the whole paper. Otherwise, you're just going to waste your time.
Okay.
You see, you're literally just going to waste your time. So, yeah, so with all this being said, right, we need to be a bit careful because, yeah, we just have to be a bit careful, you know. So let's see what we can do here with what we have just worked with. But then we also do not want to maybe fully forget this here. Let's not fully forget it, you know, because we worked hard for it, so we might also not fully forget it. In as much as we may not want to focus too much on it, yeah, we might as well keep it in mind because it definitely might come in handy. The reason why it may come in handy is because you see here, look, in our three expressions up there, there is a BE somewhere, and then FE, there isn't FE specifically, but what we know is that FE is just like what you call, there's OE there, of which FE is just double OE, you know? So let's not forget that, right?
Yeah.
Yeah, so we might as well actually focus on this because this looks like it's going to give us something. Let's actually write it down. BE over DE is equal to AE over OE. Yeah, I think this is something we should not take for granted at all. Because, I mean, where there's fuel, there's definitely fire. Because there's a BE in what we're trying to work out, there's a FE, so these fit in that way. And then in our big shape here, there is AE somewhere, of which we already can see that AE is a bit strange looking. Because AE is, I mean, like it's part of this whole section where there's CE also. And then we also have DE. DE is this tiny part, you see. So I think this definitely can help us with something. And our proportionality theorem here, where we see that this is 3:1, I think with this information and this information, we should be able to work something out from there.
Yeah.
So let us just work on that specifically. So what we know is, since we said that CE is equal to wait, let's start off with what we know here. This is 3:1. So we have information up here, right? But we kind of need information down here, because it looks like that's how we're going to be able to deal with this. That's how we're going to be able to deal with this. You see?
Yes.
Yeah. So in this expression here, we know that the BE, it's in our final expression, so that's fine. The OE is just half of FE. So let's just change that to half of FE so that we have a FE somewhere in our expression. So this, let's see, BE over DE, let's leave it as DE for now. We'll deal with it later. AE, let's leave it as AE. But then OE here, it doesn't look like it's going to serve us well there. So let's just change it to, no. Let's actually do from the top. The BE is valid, right? Let me just zoom out a bit here. So looking at what we're trying to prove, do you see that the DE is valid? Because there's a DE somewhere. So we might as well keep it like that. But then we have the BE, sorry, is valid. So we are keeping it. But then here we have DE. Whereas in our expression, they have CE. But then what we know is that DE is just half of CE. You see?
Yeah.
Yeah, so we might as well write it as that, half of CE, because it's better for us to be having these kind of letters in our expression here. For AE, we don't have anything concrete, so let's just leave it as AE for now. However, for OE, do you see that OE is just half of FE?
Yeah.
Yeah, so let's put there half FE, you see.
Yeah.
Don't worry about how we have a fraction as the coefficient here, fraction as the coefficient. It's still just normal, you know, it's purely just normal. So with what we can see here, it means that we have to see somehow how we can not have EA here or AE. We want to see how we can get more information down here so that EA it looks like we practically need to at least write it in a way that incorporates CE in there. So the one way to do that is, let's get this ratio here that they gave us to write out something down here. You see, so what we know is that AT over TO is definitely equal to AC over CD, right?
Yeah.
Because of the proportionality theorem. Prop theorem. Then we can add the TC is parallel to OD. So let's see what we can write out here. AT over TO, that's like 3 over 1 because of what they gave us, 3 over 1. And then AC and CD, let's see here, AC over CD. This is perfect, because what we want to do actually is, in this line here, we want to be able to write out a lot of this line, we want to be able to write it in such a way that incorporates the CD and the DE, so that we can eventually just have the CE over here. What I mean is, in this expression, look, it looks like if you cross multiply, you're going to isolate AC. So let's isolate. If you cross multiply here, you're going to have 3CD is equal to AC, right?
Yeah.
You see that? Yeah. So
Yeah.
meaning in your shape here, where you see AC, you can write it as 3CD. You see, this is 3CD plus CD plus another CD, technically speaking.
Okay.
Yeah. So let's just say 3CD here. Here you have a CD, and then here you also technically have another CD. You see?
Yeah, and that gives you 5 CD.
Yes. Yes, it does. Yes, it does. Yes, it does. So this AE is just 5 CD. You see? So what we need to, let's just do that. Let's just do some quick math here. Here we're technically done so far, because now, as long as you have written this out, now you can say, therefore, BE over half CE is equal to 3 CD plus this. That's going to be 5 CD, and then half FE here. Now, remember, we don't have a CD here, but then we have CE. CE, we know it's double what you call CD, right?
Yeah.
Yeah. So where we see CD here, we can just write wait, CD is half of EC.
Yeah.
Yeah. So let's just do that. BE over half CE. There's a 5 here, right? But then when we see CD there, we can just write half CE. Yeah. So let's write it down. Half CE. And then this is a half FE. So this is to highlight that with algebra and geometry, it goes hand in hand. Because here now we can just say a half there cancels a half here. And then you have like BE here over a half CE equal to 5 CE over FE. Then here we can just cross multiply. Whew, it's looking a bit scary because I'm thinking now, where's our 5 and our 2 gonna come from? But let's just see what it comes out as. So this is like this times that is gonna be 5 over 2 CE squared. This times that is gonna be BE times FE. But then because this is a fraction, you can just multiply by 2 on both sides.
Yes, and then you'll get the 2BE times FE
equal to 5 CE squared.
Yeah. Okay.
Yeah, it's this one was you can, but remember what we mentioned in the end. This is literally the last question in the whole paper. So it's not a coincidence that this is where they left all the guns, you know. But then if you look at what we were actually doing, there was some kind of a system to it, you know. We basically saw, okay, we worked this out in the previous question, fine, and then they gave us this information, right? Fine, and then they're asking us to prove this. So all we did was we said, in what we already have, what can we use to have these letters? So we have a BE already. We already have something that can get us FE. And then we said, where there's OD or DE here, I mean, like, there's a way we can incorporate CE in there. And then where there's AE, it's the whole line here. So our ratio here should be able to at least give us something we can do down here. So using our ratio, we ended up with this. We saw that AC, we may want to write it as CD in a way, because CD, one way or the other, we can eventually write it in terms of like CE. And then we were just doing it bit by bit, you know, just bit by bit. The DE, we replaced it with half of CE because we wanted to have as many of these variables in our expression. Where we saw OE, we replaced it with half of FE. because we wanted to have as many of these in our expression. And then for the AE, we firstly ended up with 5 CD, but then the CD, we wanted to replace it with something that has CE in it. So we said CD is just half of CE. And then we wrote it like that. And then we just did algebra. Half cancels a half, yada, yada, yada. And then we have the answer.
Yeah.
So you can imagine, right? More examples like these or something similar, right? It's definitely going to be on the course platform in things like the Euclidean Geometry course.
Yeah, definitely.
Anyways, if you've gotten this far, I mean, like, yep, it's good, eh? Don't forget to like, share, and subscribe. But anyways, the big idea is, the online courses, right? Because remember, you are listening to Levi from Bright Young Brains, and the big idea here is whatever it is that we're working on, right? If you need like much more deeper and more integrated explanations, then you definitely want to check out the online courses on the course platform. The link to that is in the description. And as mentioned already, for the all access pass, the discount code is BYB50. Meaning on the website, if you choose the all access pass option, right, which is the package that gives you access to like all the courses at once, there's like 2 ways to gain access to that package. You can either have like a monthly subscription of which you can cancel at any time, or the once-off fee. So say you chose the once-off fee, right? As long as your discount code is applied, then it will automatically just cut out half of that fee